Liz, you can unmute. Any other person? I think Liz is failing to unmute. Brighton?
Let's humble ourselves and pray. Have this lesson help us to come with the Holy Spirit and guide us throughout the lesson. Let's grasp the content that is going to be lowered down by the teacher and let it be useful in the nearby future. I prayed through the Almighty. Amen.
Yeah, amen. Thank you so much for the word of prayer. Good morning once again and welcome for this session. Today our major area is going to be on geometry and measures. And for this week, we shall be starting at exactly 5. So we shall not be waiting for the rest because now I do believe you have got used to the session. And so under geometry and measures, today the topics that we are going to mainly capture or look at are going to be the ones you are seeing that are highlighted in the red. So the topic we are going to look at is going to combine what we call angle properties of geometric figures. It will have some business math. It's going to involve in similarities and enlargement. It's going to involve in length and area properties, nets, areas, and volumes. And then lastly, it will involve in lines and planes in 3 dimensions. But it will also have some component of circle, mainly of these circles and a few of circle properties later on. So those are the topics that we are going to be looking at, and we are going to try to integrate the knowledge that we have acquired from each of those topics. And now that topic we are going to look at is what we call mensuration. I know you have heard about it, and when you check on your papers, it is always the last item or second last item. That last item usually look at. And under this, under mensuration, that this is the branch of mathematics where we mainly deal with things concerning length, volume, and areas of different geometric shapes. So when we talk about geometric shapes, we are looking at those different, anything you see at home, those different shapes. You look at cups, you look at buckets, you look at bottles, you look at calculators, you look at phones, all those are geometric figures. So all those figures that we look at are the ones we are going to be looking at in today's lesson. And therefore, that is where we are going to put our major emphasis. But the most important thing for you to know is to note what you call a 2-dimension figure and what you call a 3-dimension figure. So now when we talk about a 2-dimension figure, that is a figure that has only 2 planes. In other words, 2-dimension figures, they have either length or width. So take an example, when you look at a rectangle, can only have length and width. When you look at your square can only also have like length and width, or what you call side and side. So in other words, 2-dimension figures are those figures that are very flat. So anything that you look at and is flat. Take an example, when you look at a circle is also a 2-dimension figure because it is also flat. Then when it comes to 3-dimension figures, anything that you can fill in something, that one is called a 3-dimension figure, whereby you can dip something inside. Those ones are what we call a 3-dimension figures. Take an example, your cups, the buckets at home. So here you can bring your cups, you can bring your buckets at home, bottles. Yes, those things that where you buy, you can put in something and it gets into it, where you can dip in. Those are what we call three-dimension figures. So in simple terms, for them, they can have the length, they can have the width, they can have the height. You can look at the boxes where you pack your things, your suitcases. Those are what we call the three-dimension figures. So for them, they can hold something in them. But for three-dimension figures, for them, they cannot. Here you talk about your table mats and the rest of that. Those are what we call the two-dimension figures. So today we are going to look at mainly the two and mainly the three. So when they are setting the questions, these questions can have either two or it can have both of them. So that is where we are going to put our major emphasis in today's lesson. And what are some of those figures in real life? So in real life, you have met these figures or you have seen them at your different schools, at different homes. And all these ones are mathematical applications. So you have seen these such buckets being used at your compounds in schools. You have seen these ones being used as trash bins in schools. You seen this one being used as a flower pot. You have gone on to those people who are doing baking. You have seen figures of this nature being used when they are making cupcakes. But here, the one that I wanted to bring out is this figure. You have seen it, I think, when they're doing that kind of icing and the rest of that, they use them. So when you look at this one, you can easily notice that also you have met that figure somewhere. Now, for this topic, now any figure that I'm displaying or anything that I'm displaying, it means that it can be set. A question can be picked from that area and be asked because they have real life application. When it comes to here, those people who are doing farming, you might have seen this one. This one is our feeder, whereby you come, you place your feeds for the chicks, you place for your poultry, you put here your feeds, and then the birds will be able to eat. When you are carrying your water to go and shower, in case you don't, for showering, you'll find that you use these buckets. Those people who have moved along, when you are moving in different, across different areas on roads or on streets, you might have found such cones being used. They are very common around the toll areas. Those people, areas, those who have used the express highway. When you reach that toll, the toll machine where they pay from, you'll see them. Even when during the time for construction, they always use such cones. You have a glass at home. So all these ones are mathematical figures whereby we can extract questions from. You have seen even lights. Now you have seen these lights somewhere. Yes. So these are mathematical figures. You have seen, now they can ask you. Now, these ones that I've started with, these ones are questions concerning what we call a frustrum. They can ask you and they can ask you something concerning this. They can also come and ask you, for this topic is really very big. They can ask you something concerning construction. Take an example. For this one, they can ask you how many tiles can go in a room? How much money do you have to budget for when you are making your construction? So they can give you this is the square tile. They can tell you a square tile measuring maybe let me say 25 centimeters or 30 centimeters by 30 centimeter is to be put into a room which is measuring maybe 15 meters by 14 meters. How many tiles shall we need? If each box of a tile accommodates maybe 5 tiles, how many boxes shall we need? And how much money do you need? We can look at papers. When you look at these papers are rectangular in form, they can give you a piece of land and they ask you that this person has finished his construction. He wants to put pavers in his compound, and the area is measuring this and this. Therefore, how many pavers will he need? So you need to know how to do the estimation of such nature. But also when it comes to building or construction, roofing, that part of roofing, putting on the iron sheets, they can ask you to estimate how many iron sheets will the person need. Then also when it comes to construction of the bricks, they can give you the house, the size of the house, and they ask you to estimate how many bricks shall the person need when he is constructing the wall, or anything. So now you need to know that all these ones are applications of those particular questions or of mensuration. So you may not have seen them, but now you need to know that a question can easily be asked from any of these things that I'm showing you. When it goes on, you have seen these ones being also, so all these ones, you can see them, they are 3-dimension figures, because once you put something inside, it can get in there. You can dip something inside and it will hold there. So you have seen they can ask you questions concerning tanks. They can ask you things concerning paint. These buckets for the paint. They can ask you things concerning cylinders. These are flasks at times you have at school to keep in your hot water or cold water, depending on what you want to use it for. So now that is where you're going to see those people have seen. They can ask you things. If you might have seen such figures being used. You might have seen such figures. You have seen those people going for camping. They can ask you a question about this. They can tell you that 5 people are going for camping. They need a tarpaulin to use, and how then they ask you how big Take an example. When you look at this one here, the bucket, that bucket was initially a cone like that, but it was just cut to obtain this figure, or the trash bin. When you look at this bucket here, this bucket was initially, when you complete it, it was also a cone, but then it was terminated, or it was truncated at a given point, and it also became a bucket. So you are noticing that what is appearing most for many of these real life applications, you are noticing that that figure of a bucket is appearing most. That thing like a bucket, like a corn being cut, is appearing most or almost everywhere. Even when you go in your homes and you look up there, you must have noticed that figure. This one was a corn that was being cut. It was a corn that was complete like this, and therefore they went on and they truncated it at a given point. So now that is where that we are going to first concentrate on, and then from that point, we are going to go on and proceed to look at what we call a thing. Even when you look here, these were cones, but they were terminated at a given point. Okay. Now, what are some of those must-know shapes? Now, when it comes to the 2-dimension figures, I want you to, by now, I expect you to be knowing what a square. And now when it comes to a square, here, what do you need to know? You need to know how to obtain its area and how to obtain its what? Its perimeter. The same happens for rectangle. You must know its area and you need to know its perimeter. So when it comes to area, you know that it will be given by length times width. When it comes to perimeter, you know it will be given by 2 into length plus width. When it comes to rectangle, you need to know that its area is given by length times what? Width. Here, when it comes to a square, at times even if you don't use this one, you can say side times side. Others will say s squared. So all those are the same. But what is very important to know that you will get its length times the what? Times the width. So, but the most important thing, even others, in case here, since the length and the width are always the same, some people can write length squared, others can write w squared. So everything is okay. Then when it comes to even here, you may find people saying that length and width are the same. So meaning that instead of writing that, I can instead write my formula as 4s. That one is very, very okay. Or sometimes people can write 4l. Others can write 4w. It is really very okay, depending on what you want. When it comes to rectangle, it will also be like that. When it comes to the circle, you need to know its area, that the area of a circle is given by pi r squared. And then you'll come here and you know that when they ask for its perimeter, because you need to know that also a circle has a perimeter. Let me use the chart to tell me what is the perimeter of a circle. Let me see whether people can tell us. You can type in the chat quickly. What is the perimeter of a circle? Mhm. Okay, good, good. Thank you, Zulpa. Yes, so when they ask for a circle, its perimeter is given by 2 pi r. Yes, it is what in simple terms is the circumference. So perimeter is the distance around a circle. So that is 2 pi r. When it comes to a triangle, also you need to know that its area is given by a half base times what? Times height. And then in case they ask for the perimeter, then you just need to add all the sides. So those are the sum of the figures that you need to, a must know figures. Then when it comes to this side, you need to know that now, when it comes to three-dimension figures, since for them, you have to, like I've told you, for them, you have to put, you have to be able to put something. So here it differs that it's, here they can ask for volume. That is one thing. Then, if they don't ask you for the volume, they may ask for what you call the lateral surface area. Here they can ask you for the lateral surface area. Then also here, they can be able to ask you what you call the total surface area. When it comes to those figures, for three-dimension figures, the same thing will happen for a cube. They can ask you for the volume. Here, you need to know that for cuboid, it's length times width times height. Then when they talk about lateral, lateral means sideways. That is, like when you look at a cuboid is a figure of this nature, something like this. This is our cuboid. Now, when we talk about lateral, we are meaning the sides, sideways. So for when it comes to a cuboid, these sides that are parallel to each other, those are what we call the lateral. Now, like take an example, this one is one, this side we have one, this side we have one, and this side we have one. So those two sides must be parallel to each other and they must be facing each other. So now when it comes to a cuboid, its lateral, let me say lateral surface area will be only like this side here, and this side plus this side. So this is like your, let me say length, this is width and height. So its lateral surface area is going to be length and height. Even the other opposite side, which is also length times height, then plus this side and this side. So this side is width and height. So meaning that it will be width height plus the width height. So when they ask for its lateral surface area, it can be 2LH plus 2WH, which can be given as 2 into LH plus WH. Now, why is it important? Now, they can give you a box and they ask you what let me say, what polythene or what paper, what size of paper is needed to cover its surrounding. Now, that one, they're asking you to calculate its lateral what? Surface area. Remember, when you are making your packaging, always they can ask you for only this part here around it. So there, you calculate its what? Lateral surface area. Like maybe even when it may be, that is when you calculate it. But when they ask you what thing, like when you are packaging your gifts that you give to people, always you cover the whole box. So that one, it means that if you have to cover the whole box, then that means you'll be calculating the total surface area. But if you have to just cover its surrounding, then it means they are asking you to get its lateral surface area. So meaning that you don't add the top and you don't add the bottom areas. So that it comes to what we call a cuboid. Similarly, it is the same with the cube. The only difference that for a cube, all the sides are equal. So mean that in case you are getting its volume, it can be L times L times L, which will give us L cubed. Or you can call it side, something like that. So that is when it comes to that particular figure. So you need to know that. Me, yes, me. Okay. I think me, yes, me.
Teacher, could you help give more like ways in which they can set about lateral surface area?
Okay.
Because I've understood you don't cover, like you don't add in the top and bottom, but like what are more examples of ways they can set it?
Okay. Now, do you have Vaselines at home? When you look at that thing where they put Vaseline, when you look at it, you'll notice that when they are putting that packaging thing on the Vaseline, they only put it here. Like, look at those products that they sell. They always put on the sideways only. When they are putting those labels that maybe they are putting a company, you can look at the Vaselines. When they are having a label, maybe it is someone, I will find that they are putting only around it. When you look at these bottles where they put, let me say now, like here on my table, I have the one for the honey. You'll find that they only put around it, the sticker, in other words, the sticker, they put it around it only. They don't put it at the top, they don't put it at the bottom. The same thing will happen to add some of those packaging materials. Mainly they use it mainly when it comes to the packaging. They only put it around. Yes, so you put it around. Those things whereby the package, they put it around. They may ask you, what is the size of that sticker? Yeah, something like that. Yes, Juliet.
Good morning, sir.
Morning.
I'm requesting to know how do we find the total surface area?
Okay. Okay. Now, if it comes to total surface area, it means that we are going to add the bottom and then the top. So on top of this one, we shall add, allow me to first mute. So on top of this one, on top of the sideways, we shall add on the top and then the bottom. So when you look at the bottom has this one, has the length and the width. So I'll add on the length and the width. Then I also go up. Then also up, I have length and the width. So mean that these are going to be two length and width. So on top of the lateral surface area, we shall now come and say the total surface area is going to be 2 into length width plus length height plus width height. Now that is the total surface area when it comes to a cuboid. Then when it comes to a cube still the same thing. The only difference that for a cube has the same sides, that the sides are equal. Meaning that if the sides are equal, instead for it, you'll have its volume as maybe L cubed or A cubed. Then its lateral surface area, it's going to be since I've told that for it you must involve in the height, for it you involve in the height. So the height must come into play. So for it now, it can be, since the sides are equal, now for it when it comes here, it can be 2. I'm using for a cube. Its lateral surface area will be 2 into length and height. We have said they are the same. So mean if I take L squared plus, now this is going to be L squared. So this will be 2 into 2L squared. Then it can be 4L squared. So when it comes for the cube, for its lateral surface area is always 4L squared, whereby L is the length for the sides. Then when it comes to its total surface area, instead of right now, it will become, remember this is going to be 2 into this one is going to be the same. Same. So here I will have 2 into 3L squared, which will give us 6L squared. So for a cube, it will be 6. Now, I didn't start these ones by mistake. I want you, these are the must-know shapes. You must be able to find its volume, lateral surface area, and then the total surface area. Make sure you know for these two shapes, for these ones at least. Yes. Then the rest can come in later. But these are the most important ones. A cuboid and then a cube. A cylinder can come in. And when it comes to a cylinder, for it, you know that a cylinder, its volume is given by pi r squared height. That is for a cylinder. Then when they ask for its, now when it comes to figures that have something like a circular, that one now we don't call it lateral. Instead, we call it the curved surface area because it is curved. And to get that curved surface area, now take an example for a cylinder, it is 2 pi RH. That is the curved surface area of a cylinder. Then when it comes to its total surface area, it will be the curved surface area 2 pi RH, then plus. In case it is an open cylinder, it will be pi r squared. In case it is this is for an open. In case it is a closed cylinder, then it will be 2 pi RH plus 2 pi r squared. Because when you look at a cylinder, it has two circles. You'll find that it has a circle down and a circle up. So the area of this upper circle is pi r squared. The one down is also pi r squared. So meaning that pi r squared plus pi r squared, you get to pi r squared. But that is a circle which has two. That is a cylinder that has the two circles. Then in case it has one circle down and it is open up, like now, like your cup, then that one, if it is like your cup, that one is an open cylinder. But if it is like let me say these tins where you put let me say you put ginger, these tins where like you put sugar and the rest of that, those ones are closed. Okay. For a cube, I think I've showed you, Daniela, how we get for the cube. The cube doesn't have, because the sides are flat, so for it we call them lateral. That one called lateral surface area. Then for the ones that are curved, those are the ones we call the curved surface area. Okay, lateral applies to the figures that have, let me say, flat surfaces. A flat surface is a cube and a cuboid. Those are the ones that have a lateral surface area. Then other figures that have a curve, we call them curved surface area. And when we have said lateral means sideways, because like to take an example of your room. Let me take an example where you are seated at home. You are not seeing that you have those walls surrounding you. Those are what we call the lateral. That one is what we can call the lateral. Remove the ceiling and remove the tiles down. Remove the bottom of your house and remove the upper part. Now the sides that remain are what we, that side, the area of those sides are what we call the lateral surface area. Where you are seeing where the window is, the door is, this side and the opposite side. Those are what we call the lateral. Remove the upper and remove the downer thing. So that is briefly about that. The rest of it, we are going to look at them in details. Okay. Now, what do you need to take note? One, when you are attempting scenario questions concerning mensuration, one, you must define and also be coherent. Like, let your work have a flow. Do not just write things from nowhere. Let us see that flow of your work, that from one step, it leads you to another. From this step, it leads you to the other. Because for it, remember, for mensuration, it doesn't have a specific way how you can start. So anything you are starting, make sure you define it. Take an example. When I'm working out, I'll have to say that the number of, maybe in case it is about tiles, I will say the number of tiles in a room. Then you show how you are calculating it. But don't just come and put figures. Some of you are used, you get an answer, you go on without defining what you are doing. So by defining what you are doing, you are giving someone who is marking your work a flow that your work is flowing. Do not just write things without defining what are you doing. Because here you need to write some of those words that now are finding the volume of the bigger cone. Finding this and this. So that is what I'm calling defining and being coherent in your work. Take an example. They have told you to estimate the amount of money that is needed maybe to put tiles in your room. You cannot tell me that you are going to first find the amount of money, and then after you find the tiles that are needed to fit into your room. There is no coherence, because now we need to know how many tiles do you need, and then after you estimate the amount of money that you need. That's what we call defining and being coherent. Number two are units. Now here, when it comes to units, I want you to take note that when we are calculating things like volume, their standard units can be liters. So here I need you to know that whenever they talk about that, convert your how many liters, because they can give you your work in centimeters cube, in centimeters, but they want your work to be in liters. They can ask you, how many liters of the paint shall we need? You need to remember that 1 centimeter cubed, 1 liter is equivalent to what? 1,000 centimeters what? 1 centimeters cubed. So you need to be remembering that, such that when you are making your calculations, you know what you are going to do. Number 3, write a formula where necessary. Some of these things may require a formula. Some may not require a formula. So for anything that requires a formula, take an example, calculating volume, what. Yes. Faizo, I'm going to talk about the cone in details. Yeah. Things that concerning getting the formula, please make sure you write the formula. Let me take an example. For those figures we have looked at, write its formula, that length times width times what? Times height. Like this times this, like this times this. And even for some of these ones, they are going to require you to draw. Make that sketch, please. Yes, for things that require, for many of these things, in order for you to do this number very well, you'll need a sketch. Like it or not, please put the sketch there. Yeah, you may find that they have given you a support material without a sketch. Make your own sketch and let it be a good sketch, clearly indicating what you have to do. Now, in your conclusion, let us conclude with evidence. And here I want you to reason always. Take an example, you have calculated and you have ended up with like this as your liters. Now, I expect you to have this as your approximate, but then you ask yourself, can someone be able to approximate 4.5? Maybe when someone is fetching water, then you need to come back and take a reasoning on how you have to conclude. Then, like I've already emphasized, you make sure you know the volume and area formulas, but also you are going to need some basics of trigonometry, because sometimes they may ask you the point at which the thing is leaking. They may ask you to be able to calculate those angles. At what angle should the house be elevated? When they are putting the roofing on the house, always they are elevated at a given angle, not that they elevate them at any angle of their choice. Always they have some particular angles where you are going to, where you need. So please make sure you know some basics of trigonometry, mostly how to use sine, how to use cos, and how to use tan to find the angles and to find the length, because you are going to need those ones. Then, what are the don'ts, things that you need to avoid? One is what we call premature approximations. Take an example. If you have not yet reached your final answer, the final answer that is needed, do not go on truncating, reducing the decimal places. No, reduce them at your final answer. Take an example. You are calculating maybe the liters it can hold. For you to approximate, make sure you do it at the end. Let me not see you here, your volume, you have got your volume, and you approximate to maybe 0 decimal place. You go to the next one, you approximate to 0. Before you reach your final answer will have a lot of errors if you do what you call premature approximation. So do not go on rounding off until you reach your final answer. If here there is need for you to round off, let me say the number has very many decimal places, then let me advise you that for those ones where you see the number, maybe you have calculated your volume and it is giving very many decimal places. Now for that one, at least, I've used the word at least, write to 3 decimal places that volume, and then go like that until you reach your final answer. But don't terminate to 0 decimal place. Don't terminate to 1 decimal place. Don't terminate to 2. At least have 3 decimal places, such that you are exactly in the range of the exact answer. Number 3, do not mix units. At times they may give you their volume when it is in liters. Another one, they give you when it is in centimeters, and then they mix in the units of meters. When you are making any multiplication or you are doing anything, make sure that the things you are multiplying are in the same units. Take an example. I don't expect whereby they have given you in meters, and then you are multiplying, and another one is in centimeters, another one is in meters, and you multiply such thing. You cannot multiply them. So make sure that the units you are dealing with, all of them are in the same units. In case they are meters, first deal in meters, and then after, convert to the units that may be required. So that one, yes, so make sure that one. Then the last one is going to be, please do not cram formulas. Some of you cram, others I've seen some students who go when they have written them somewhere. Please, that one, don't risk your future. Yeah, don't not cram, but understand how those different formulas can come about. But also, I know, I have not yet confirmed, but I know we have logbooks. Those logbooks have those formulas behind. So you may ask for a logbook, check behind, you'll be able to see those formulas. They are there in those logbooks. So just ask, and then you'll be able to have. Now, what is our major area for this today? We are going to look at the basic concept about what we call first term. A first term is what we are going to look at. There is no R. Yes. Now, when they talk about a first term, it's just like slicing off the top. Like I've showed all those figures I've showed you, there is something they sliced out from the top. So it was, let me say, it was a cone of this nature. But what they did, they went and truncated and they cut, and therefore it remained like this. So those buckets you were seeing, the cups and there is and what, so it remained like this. Now today in our lesson, we are going to look at how do we calculate, how do we determine, how do we utilize in order for us to find out this one for the first one. And that is what we are going to look at. And now I want you to take note that in real life or in life, the mostly common used first terms are a pyramid and a cone. Yes, the first terms that are being generated mostly, and even at this level, you are going to find that it can either come from a pyramid or it can come from a cone. Those are the two common ones. The rest can just come in, but those are the two most common ones. And if you have noticed, take an example. When you look at this, those who have seen, this is now a first term for a pyramid. The figures I'm showing you, these are pyramids. When you go to supermarkets or to those people who are selling popcorns, in those expensive areas, you'll find them using tins of this nature. This is still a first term of a pyramid. Those who have been to Lubaga Church, at the front, you might have seen this one, this figure here. This one is still a first term of a pyramid. It was a complete pyramid, but then they had to truncate it. Truncating means like terminate something from it, or cut some. Truncating means like you terminate something. So something was sliced off from the top. When you go to some petrol stations, you'll find such things. Those who have been to areas where they construct, at times I fail to get a picture, but those who have been in town recently, there are some things they use along the road which look like this. Yeah, those ones are also first terms of pyramids. So that is how they can use them in real life. Now here they can ask you a question, or they can give you a question that maybe someone wants to construct a stand that is in the form of a first term, like this and like this, and they ask you how many bricks can the person hold. In case maybe some people construct feeding areas and the rest of that. If you have seen feeding areas for cows, for goats, and the rest of that, in most times they're in this shape, but when they are upside down, you find this shape and then you put it upside down. Those who have feeds at those who have cows at home, you might have noticed that they are feeding things, troughs. They have a way they are carved down here. So even when you look at the things for getting honey and the rest of that, they have a shape of that nature. So in most cases, that is when it comes to a pyramid. And this is what we call a frustrum. A frustrum is that incomplete pyramid, that incomplete cone, whereby they have removed the top, but when you try to figure it out, you can make a complete one. So those are what we call a pyramid. So that's how they manifest themselves in real life. So mainly they're used in construction purposes. When it comes to construction, they are always used. Now, what comes to a pyramid? Now, when you look at a pyramid comes from a prism. And when we talk about a prism means a solid shape with flat sides. Any shape that is solid, that has flat sides, we call it a prism. And always it has two sides that have the same shape. Now, when you look at this, let me ask members to tell me what is the volume take an example. This figure here, I want you for this prism. I know you know its special name. What is the volume? Can everyone type in the chat? What is the volume of this figure here in the chat? How will you calculate its volume? Type in the chat. I want to see what is the, good. They have told us that the volume is equal to length times width times height. Yes. For this one, you can say this is its length, this is its width, and this is its height. Now, in order for me to find the volume for this pyramid here, this pyramid you are seeing, what does it mean? When you look at my segment, this is 1, this is 2, and this is 3. Now, in order for you to find the volume for the pyramid, you can notice that when you, let me use water. When you put water in this pyramid here and you pour it in this prism, you will notice that in order to fill this prism, you will need 3 of these pyramids. So in other words, this pyramid, when you put water and you pour inside, it only covers 1 of all the 3 parts of the prism. And therefore, its volume is given by 1 part of the 3 parts it covers in this prism of its volume, which is length times width times height. So when they ask you to find the volume of the pyramid only, when you pour water here, it only covers 1 of all the 3 parts. So that's why in the formula for pyramid, you have 1 out of 3. So 1 out of 3 comes from here, that it only covers 1 out of the 3 parts of the whole prism. So now its formula is given by a third. Then this length times width, it is what we call the base area. Then times the height. Now, the base area will always depend on the shape of the figure you have. In case it is a square, you use side times side. In case it is a rectangle, you use that. So it will depend on the shape of the base. But one thing you need to know that always it covers only 1 out of the 3. That's why when those people who are packaging, they prefer these ones compared to the prism. Very few people will package using cuboids. Those are very few people who package in that kind of format because they know that a prism takes on a smaller volume. So for you might look at it as something very big, but in actual sense, it is taking in something very little. So when you are packaging and you're going into business, you need to know what you need to package in, yeah. So that's why for people who are packaging, always they are strategic. Even in construction, someone constructing, now like you have looked at those houses, for these ones here, when they're constructing, when you use this kind of when you use this one, you minimize on the costs, you minimize on the bricks that are going to go and the rest of that, than someone who uses a solid thing of this nature. So here you use a lot, yet here you use small or you use little. So they are very good when it comes to construction and other things of packaging. So that is what we call a pyramid. So please, this is the formula for the volume of the pyramid. But like I've told you, it can be cut into a frustrum. So when it is being cut as a frustrum, then it means that you are going to get this volume for the bigger minus the volume for the smaller. But that one, you are going to understand more when I'm talking about the cone. Please do not forget that 1 liter is equivalent to that. Now, what are we going to look at? We are going to look at now the second frustrum. I want you to tell me, when you look in the chart, this is a cone. This is a cone, and this is a cylinder. In the chart, tell me, how many glasses of water of a cone do you need to put in this cylinder to get full? Daniela said 3, but caption is saying 4, 3, 3, okay, 3. Yes, good. It is 3. So now also I want you to take note that when it comes to a cone, a cone comes from a cylinder. Now, these things are related. Now, what do you need to know? That a cylinder, its formula is always given by pi r squared h. That is the volume for the cylinder. volume of a cylinder. Now, in order for you to be able to come up with the volume for the cone, you ask yourself, how many tins of a cone do go inside a cylinder? So when you look at it very well, when you pour your water into a cylinder, one cone can only fill 1/3, 1 out of all the 3 parts. In other words, you need 3 cones in order for you to fill one cylinder that are made of the same material and the same space. Therefore, to get the volume of a cone, we shall always say is equal to 1/3 of pi r squared height. So that's where that formula comes from. So meaning that when you are coming up with a cone, you need to know a cylinder. When you are coming up with a pyramid, you need to know a prism, or what you call a cuboid. Yes, Sobi.
Good morning.
Yes, good morning.
So I beg your pardon on the origin of the volume of a cone.
Oh, now the volume of the cone, that a cone, when you are making a cone, if you have ever made a cone, you'll make it like a cone, like when like a cone comes from a cylinder. So when it comes to a cylinder, the number of cones that can fill a cylinder, when you put water in a cone and you place and you pour it in a cylinder, the number of cones that can make it full, make a full cylinder, there are 3. So one cone is equivalent to, it covers only one part. Like when you pour one cone inside a cylinder, it will only cover one part out of the 3 parts of the whole volume. So when it comes to the volume of the cone, that's why we say 1 out of the 3 of the volume of the cylinder of pi r squared height, because one cone is equivalent. Let me hope so we are getting it.
Now, teacher, okay, like, I'm just asking, how does it come? Okay, is the cylinder like, do you estimate that the cone was cut out of that very cylinder?
Yes, that very cylinder. Yeah.
And that is it, that one cone. Okay, one cylinder is equal to 3 cones.
Yes.
Okay, thank you, teacher.
Okay. Yes, you can even try it at home. You can try it at home. For you, what you do, you make your own cylinder. You make a cylinder, and then after making that cylinder, you go on and cut out a cone. You'll find out that in order for you to make it full, you'll need 3. So that's why when they're packaging, I've told you that people who are packaging, the reason why they keep on using cones, it's because cones take on small volume than using a cylinder. So meaning that if you package your thing using a cylinder, you'll use a lot of material. Yet when you use a cone, you use small material. But because for us people who see, we think that it is very big, yet its volume is always very, very small. That's why when they are packaging things, like you have noticed these buckets they are making, most of these figures, the reason why they do them like this, they want to minimize materials. Otherwise, if they are to use the complete one, a complete cylinder, they would have used a lot of material. But when they use such, they always keep on minimizing. That's why when it comes to these figures, you'll find that a tank is very expensive. Reason being that for it is a cylindrical thing. It's made of a cylinder. So it takes on bigger volumes. Yet for a same size that is a cone, you'll find it very, very cheap. So that's why they are used in those materials. Now, hope now we have understood those formulas. Now, those formulas are going to be very key when it comes to doing these scenario questions. And we are going to start with our first scenario. Now, this is our first scenario that we are going to look at. We have this gentleman. This gentleman is called Christopher. He's a man in the village who fetches water using a bicycle to earn a living. He uses this bucket of height 63 centimeters, bottom of diameter this, and a top. Your family is organizing a party and Christopher has been contacted to fetch water. He has to fill the 500-liter tank. If he's paid 2,000 per bucket, what should the family budget for to cater for Christopher's task? Now, what is important? What is important for you to know? This one I've used just a bucket. For you to get the amount of water that this bucket takes in, we are looking for the volume. But this bucket came from a cone. In other words, this is a first term of a cone. So meaning that when you are reasoning or when you are working out, you are going to first bring in that idea of a cone and you make a complete figure. So take an example. What am I going to do? I'm going to come and I say, this is how my bucket looks like. My bucket looks like this. Here it has 48 centimeters. Here it has 30 centimeters as my diameter. And here its height is equal to 63 centimeters. Now, this is a first round. So in order for you to do it, you are going to complete it like this. So this is a completed one. Now, after completing it, what are you going to do? Because you don't have this other part of the cone, here you are going to come and I say, let me estimate this to be the height, which is small h. But now here we are going to bring in what we call similarities. You need to remember what we call similarities, whereby we get the, and under similarities, you need to remember we have what we call linear scale factor, whereby here you compare length of different sides. We have what we call area scale factor. Here you compare the areas, and we have what we call the volume scale factor. You compare the volumes. But since here we are looking at length of different sides, and like this part that is being cut off is always parallel to the original one, it means we are going to deal with linear scale factor. Now, what are you going to do? I'm going to come and I extract a figure. So when you look at this, you can say that here I have a big cone, the bigger one. This is a big cone being formed. And when you look at this big cone, its height from here up to here, it is of a height of 63 plus h. But also I have a baby cone. I have this baby cone here, of which height is equal to h. And its diameter here is equal to 30. And for this one, its diameter is equal to 48. Now here is where you use your similarities, where we will have the bigger and the smaller. Alternatively, in case you don't use that, you can come and extract and say, here, I'm going to come here, I extract and I use the radius, whereby I'm going to form a figure of this nature, like this. Whereby, now I'm going to have two triangles inside, whereby this from here up to here is 30. So when I divide into 2, I'll have 30 divided by 2, which is equal to 15 centimeters. Then this is 48. When I divide by 2, I'll get 24 centimeters. But the height here for the original was 63, and this is my h. So members, let me know. On 1 and 2, which one can we use? Just put for me in the chat. Should we use 1 or 2? Which one is going to be easier for you? 1. Okay, people are saying 1. Okay. Any use, you get the same answer. Any use, you get the same answer. But we can do both. It is okay. Now, when we use 1, I'm going to compare. I'm going to say using similarities. Using similarities. Now here, I'm comparing. You compare the big, let me write for you here. You compare the big diameter and the small diameter. Here, I'm going to compare the height. I'll compare the big height for the cone divided by the small height for the cone. Now, please take note. When you start with big, small, please maintain it. Big, small. So for the big diameter here, I'll have my 48. divide by the small diameter, which is 30, is equal to the big area height, which is 63 plus h, divide by the small height, which is h. Now, what is the next step here? You're going to cross multiply. So I'll have 48 times h is equal to 30 into 63 plus h. So this will give you 48h is equal to, when you open brackets, you'll have 30 times 63 plus 30 times h. So this will give you 48h is equal to, now you multiply, you use your calculator, you say 30 times 63, which will give you 1890 plus 30h. So you collect like terms, you take the 30 this side, so I'll have 48h minus 30h is equal to 1890. So 48 minus 30, you'll end up with 18h is equal to 1890. So you divide by 18, divide by 18. And therefore your h will equal to 1890 divided by 18, which will give us 105 centimeters. Meaning that the height of this small cone is 105 centimeters. Alternatively, those now who want to use this second one, also you'll get the same number. Now here, when you are comparing, you're going to compare the big one and the small one. So I will say 24 out of 15 is equal to 63 plus h divided by h. So when you cross multiply, you'll have 24h is equal to 15 into 63 plus h. So you open, you say this is 24h is equal to 15 times 63, which is 945 plus 15h. So you collect like terms, 24h minus 15h will equal to 945. So here we'll end up with 9h is equal to 945. So when you divide by 9, you'll end up with your height as 105 centimeters. So for you, use any of the approaches that is easier for you. Any approach you use is very okay, but you use that one that is much easier. Yes, Ashraf.
Good morning, sir.
Good morning, sir.
I would like you to pardon.
Where?
From where I began from using similarities.
Now, when we are using similarities, when we are using similarities, we compare the same sides. Allow me to. When we are doing similarities, always we compare. We do what you call comparing. Now, and when we are comparing, we always compare the same sides. Take an example. In case I have this is, when I'm using those similarities, take an example. I look at figures. Let me say, this is my figure. This is capital, okay, this is big R, and this is small r. Then let me say, this is maybe capital H and this is small h. So when I'm comparing, I get a big out of small. Big is equal to big out of small. But what I'm referring to is that here you have the bigger one, which is this, whereby you have R and it's capital H. Then you have a baby one, which is this, whereby this is small r and this is small h. So when I'm comparing, I compare the same sides, this side and this side, because all of them are radius. So I say capital R out of small r. Then I compare this bigger height is equal to the bigger height out of the small height. In case they are, in case it is for all the figures that we are going to be dealing with, always get the bigger out of the small, bigger out of the small. But here we assume that the angles are the same. We assume that the angles here are the same angles, or the angles are what? Are similar. So that is what we call the law of similarities. Similarly, what we have done is that we had our bigger cone. This was the bigger cone, and we had a baby cone. Now, when I'm comparing, this one is diameter. Let me say this is the diameter, capital D. And we had a smaller cone whereby its diameter is smaller d. Then we had our height of this bigger cone, of the mother cone, which is h. And then I have this smaller one, which is small h. So when I'm comparing, I'll compare the bigger diameter, which is capital D, out of the small diameter, which is D. Then I compare it with the bigger height, which is capital H, divided by the small height, which is h. So you compare what you have. Now for that particular one, we had here our 63. So I think it was what? It was not 6, it was what? It was 48. So I'll get the 48, the bigger, divided by the smaller diameter. So here they had given you it as 30. So that diameter is equal to 30. Then I go to the height. When you look at the height, they only gave you the height from this point here, but they didn't give you the complete height. So that's why we got our height by adding on what they had given us as 63. Then this part that was cut off, since here we have assumed it is h. So to get this bigger height, I'll get the 63 plus this small height, which is equal to 63 plus h, divided by the small height, which is h. Then the next thing here you do, you're going to just cross multiply. And when you cross multiply, this h multiplies the 48, you end up with 48h is equal to this 30 multiplies this side. It becomes 30 into 63 plus h. But when you are opening the brackets, this 30 multiplies the 63, this 30 will multiply the h. In other words, it says 30 times 63 plus the 30 times h. So that's how we have been able to come up with this. And then after, you work out your mathematics. Hope that is very fine. Okay, I take on one question. Ashraf?
Yes, sir.
It is fine now?
Yeah, thank you.
Oh, okay. Jackie? Hope Bora fine? Yes.
Like after finding the height, don't you find also the height of a big cone, like getting 63 plus h, then after you say 63 plus 105, getting 168?
Yes, that's where we are heading. Yeah, that is it.
Okay, thank you.
Okay. Yes, another one? Helus?
Yeah, good morning, sir.
Good morning.
For me, my question is, what if they give you the bucket, let me say bucket of frustrum, when they have not given you the height? What can you use to get it?
Oh, now that one, you check out, they must have given you either area or volume. Their volumes.
Yeah.
So now there you use the volume scale factor or the area scale factor.
Okay.
Okay. Now we go back. Now, when we go back, now we have our bigger. This is the bigger cylinder that we have. And when you look at it, here they told us it was 48. And its height now, remember now its height, we are going to add. It had, here initially, it had 63, but we have found out that this part that was cut out is 105, meaning that its total height, we are going to add the 63 plus the 105. And members, when you add, I think you get 168. Then when it comes to the smaller cylinder, you have noticed that for it, they gave us as 30, and we have obtained its thing as 105. Now, since we are looking out for the capacity of water that can go into this part of the bucket, what are we going to do? We are going to get the volume for this bigger part, for the bigger cone, and the volume of the small cone. So, and we have said that volume is always given by a third pi r squared height. Now, we are going to find the volume for the bigger and the volume for the small. So allow me to call this. Now here, when I'm writing, I'll say the volume of the big cone. Then I make my calculations. So we shall say volume is equal to a third times. Now here I want you to take note. Never use 3.14 unless the question has stated. Whenever they don't state it, for you stick to 22 out of 7. Never use it unless the question has stated it. then times the radius. Now, remember, this is diameter, our circle. Do not make that mistake. So you say 48 divided by 2, it will give us 24. So here we shall have 24 squared, then times the height, which is 168. Kindly make your calculations and put for me the answer you are getting in the chat quickly. Yes. I want to see which answer people are getting. You put in your 25344. Yes, you can put in your calculator as pi. It is fine. Trevor Banis, kindly make your calculation again. Make your calculation again. Yeah. Yes, looking, I'm just, yes, Nakato. Nakato has this. So kindly check out. This is the one we are supposed to have. 76 centimeters cubed. This is the volume for the big cone. Then I come for this small one. Then I will say, for the small one, the volume for the small cone. You indicate it there as you write. Then you still say it's equal to a third pi r squared height. So this one will be a third times 22 out of 7 times the radius. Remember now this is diameter 30. So meaning you say 30 out of 2, which is equal to 15. So this will be 15 squared times the height, which is 105. So here, when you place you place all your calculator, and then you get the answer. According to what I'm seeing in the chat, it is this centimeters cubed. So this is the volume for the small one. Now, since we are interested in this part of the bucket that is going to hold water, meaning that since this is the part that was cut out, in order for us to get the volume of the part that is remaining, it means we shall get the volume for the big minus the volume for the small. So this one will give us 101,376 minus 24750. And therefore, this one is going to give us our answer as, I don't know what you're getting. Are you getting something like this? Centimeters cubed. So that is now the volume of the bucket that is holding the water. Yes, okay, Nakata has got the answer. So that is the volume of the bucket. But when we go back to our question wanted us to find that if it's paid 2,000 per bucket, what would they budget for? Remember, now we are dealing in liters. Yet our answer we have got is in centimeters cubed. So what are we going to say? We are going to convert and find out how many liters can this bucket hold. So we have said that 1 liter is equivalent to 1,000 cubic centimeters. So you ask yourself, how many liters are there in 76626? So in simple terms, it means that you are going to say 76626 divided by 1,000. And therefore, here your answer is going to equal to 76.626 liters. Now, here in your heading here, when you are making your work, I will say finding the number of liters, finding the number of liters in the bucket. So that is what you are going to do. Now, this is why I'm telling you, since we have not yet obtained our final answer, we are going to first continue and find out how many buckets will the person need. So here, I don't expect you to round off because this is already to fill decimal places. So you continue working with it. Now, the next one I'm going to go on and I say, now, the number of buckets. How many buckets will the person fetch? So I'll say the number of buckets. Now, to get the number of buckets, what do we need to know? It means that we are going to get the volume of the tank, divided by the volume of the bucket. So, the volume of the bucket. So, you have noticed that the tank has 500 liters, according to the question. Divide by the volume of the bucket. So the volume of the bucket, we have got that it has 76.626. So because they has to fetch, that is what? 76.626. So you divide. So when you divide quickly and put your answer in the chat. What are you getting? Yes, Tracy.
Good morning, teacher.
Good morning.
I was asking that instead of using similarities, is it possible for you to use a formula? Because according to the research I made, the formula finding the volume of the first one.
Okay, I'm going to talk about it.
Okay, teacher.
But it is okay. Okay, people are getting 6.5252, and these are buckets. So now you ask yourself, can this gentleman carry 6.5252? So you ask yourself, will the person, now 6.526, meaning that you will go and you will bring, and you will be somewhere. So here is where we make now. Since now we are going to our final answer, here we shall say, the gentleman or Christopher will fetch approximately 7 buckets. So here you approximate, but use these signs because we can't carry a half a bucket. Because now, much as, remember, even if it is a half, you cannot estimate this 252. And remember, when they are paying him according to the number of buckets he has carried. Yes, so now we are going to round off. So we shall round off to 7 buckets, that you will carry approximately 7 buckets. But now they ask you, how much should the family budget for? Now you say the family would budget for, since he is going to fetch 7 buckets, what does it mean? It means that now you'll come and say that each bucket is sold at 10. So you'll say the cost. I will say the cost of the task. The cost of the task is equal to the 7 buckets times the 2,000 is paid for the bucket. So this one will be 7 times 2, that is 14. So I'll have 14,000 Ugandan shillings. Then I'm going to make a conclusion, and I will say that Christopher or the family needs to budget for 14,000 for the water that Christopher is going to be fetching. So that's how I'll make my conclusion. What if I get 6? What if I get 6.009? Now, what's wrong with leaving it as the decimal point? Now, leaving it as the decimal point is like when you are reporting and they ask you, how many buckets did you carry? And then you say, I carried 6.5 and a quarter and a quarter. Yes, it does not sound well. So you say instead of you bringing a half, you would rather bring the 7 buckets. And now this is where even it makes more sense, because when you say I bought 7 buckets, even they can say, okay, that is good. Yeah. So you make an approximation. Yes. Even now here, even you have to reason, because like let me say, in case you had gotten your answer 6.23. Let me say, in case you had gotten your answer 6.23. Like here, why we don't say 6 buckets? Because remember, the tank is for 500 liters. And for them, they want it full. So mean that when you bring 6 buckets, you have not filled the tank. Meaning that the water you have bought for these people is not going to be enough for their party. So it is better always to bring, in fact, to bring the excess rather than bring something that's not going to be enough. Take an example, in case you had got your answer 6.23, still you go on and reason and say, when I bring 6 buckets, will the water be enough? The water will not fill the tank, meaning that it will not be enough. So there, your reasoning must work for you. Yes, your reasoning must work for you very well. That if I bring something less than the required, it means that the tank can never get full. So if it doesn't get full, it means that you have not done your job well. So the water will not be enough. So people will suffer. So it is better bringing excess than you bring something that is less than the required. So that is what you need to base on when you a reason. Yes. Why are we writing 3 decimal places? The reason why I've told that the reason I want you approximate at the final. Those number of decimal places make you get closer to the actual answer or to the exact answer. But the moment you terminate from the start, it means that you are going to get an answer that is far much bigger than the required. And yet we don't want you to be able to, yes. So we don't want you to get something that is much bigger, because now here, if those people who, let me say, who approximated that this is 77, you will find out that you are getting your answer more than the 7 buckets. You find yourself getting 8. So mean that the family will be making a loss, because this person will go back for 8 buckets that is not required. So that is how you approximate. Now, that was just the start. Let me know in the chat whether people we are almost on the same page. Before now we are going to the next one. I'm adding on the level. So the first level was a bit easy. Now I want to add on the level, but I want to know whether at least you have got something. Okay, people are saying yeah. Okay, now what is the second approach? I know we have we have another approach that we can use for finding the volume of the frustrum. And now that approach is using a formula. Now that formula, why I don't, okay, it is okay to use, but like I told you earlier on, do not cram the formulas. Do not cram the formulas. So my only worry is for the people who may cram it and they reach the paper when they have forgotten it. Now the other formula is of using for a frustrum to calculate it directly. It is given by volume is equal to 1/3 pi h, but allow me to write it on its own slide. Allow me to write it on its own slide such that people can see it very well. Can see it very well. Now the other one, we have said that this is our frustrum. This is our frustrum, whereby we have this being cut like this. Now, this one is what we call the height of a frustrum, so I can call it h. Then I have this one as the bigger radius, which I can call r. Then this one, I can call it the small radius, which is r. Now, the alternative formula of finding it direct without getting the bigger minus the smaller and like that, the formula is given by 1/3 pi h into r squared plus r squared plus r. That is how the formula is given. But you can let me know, in case you want to know how it comes, you can let me know, we can do it. In case you don't need, then we can leave it. But it has the way it comes, and it comes from similarities. It comes from similarities. That's where it is. People, do you want us to derive it? You can let me in the chat. Yes. Let us derive. Okay. Okay. People want to know how it comes about. Okay. Allow me now to erase how it comes about. Okay. Looking in the chat. But those who have understood that one, please for you go on. Now, let me complete this cone here. You're going to allow me to complete that cone, and I'm going to call this, you're going to allow me call this here height h, that one, small h. Now, by similarities, I want you now you're going to pay a bit more attention. Now, here by similarities, we shall say that our big R divided by the small r is equal to the height. So now for this time, it's going to be big H and small h. So I'll have capital H plus small h divided by the bigger, this one, which we are calling the bigger H here. Now, when you cross multiply, you're going to get RH is equal to R into H plus H. So this will give us RH is equal to R capital H plus RH. Now, what don't we want? One of the things we don't want is this bigger H and the small r. That is the thing we are going to eliminate from everything we are going to do. So meaning I'll have RH minus R capital H is equal to RH. Now, since I don't want the height, this H here for the small cone, for this part that was cut, I'm going to factorize it out and say H is equal to R minus R, which is equal to RH. And therefore, my H can be given by RH out of R minus R. Hope members that is okay. Is that first step okay? Let me know. Okay. Now, after that, we are going to go on and ask ourselves, what is the volume for the bigger cone? Now, the volume for the bigger cone, still we shall say is given by a third pi r squared. Hope everyone is seeing. Then times the height. But the height for the bigger cone is h plus h. That is the bigger cone. Then the volume for the small cone is given by a third pi r squared, the small r, then times h. Therefore, to get the volume for the frustrum, we shall get the volume for the bigger cone, which is pi r squared, h plus h, minus the volume for the small, which is pi r squared h. Now, when you look at them, you're noticing that a third and a third is the same, pi and pi is the same. So I can factor out and I say a third pi into, here I remain with r squared, into h plus h, minus, here I remain with r squared h. But we have already obtained our h from here, that h is RH out of r minus h. But I can first open here. So here I'll have a third pi into r squared h plus r squared h minus r squared h. So now, since we have already obtained our h, I'll put it there. So I'll have a third pi into r squared, but our h is RH out of r minus r. Then I'm going to continue plus r squared h minus r squared, but this capital H is the same as RH out of r minus r. Now, this will be equaling to a third pi. Now, r minus L is the LCM. So being the LCM, I'll say r minus r. So I'll multiply it here, here, and here. So the first one here, it will cancel. So I remain with r squared, RH, plus for the second one, it is going to become r squared h into r minus r, then minus the third step, it will cancel. So it will remain with r. Remember, there is r cubed h. Now, this will give us a third pi. Now, what are you noticing? Here, I'm going to open to be r squared RH plus r squared HR minus r squared HR minus r cubed h. All of it out of r minus r. So here inside, you are going to notice that some things are going to be cancelling out. This is r squared RH and this one. So these two are going to be cancelling out. So I remain with a third pi into r. R squared times r is r cubed h minus r cubed h. So you are going to notice that h and h is common. So I'll have a third pi h into r cubed. Oh, here, do not forget there is r minus r. R cubed minus r cubed. Now, you're going to come to know later on in math that when I have a cubed minus b cubed, or you'll try it out in your free time, is the same as having a minus b, having a squared plus ab plus b squared. So here, it's going to be the same as here, that is out of r minus r. So this will be a third pi h into here inside, we shall have r cubed plus this is going to be r squared plus r squared plus r into r minus r out of r minus r. So this r and this one will cancel, and therefore you remain with your volume as a third pi h into your capital R plus the small r plus RR. So that's how it comes about. Yeah. But in case there is anything you have not, just follow the mathematics. But there is no need for you to know how to derive. The third last step. The third last step. This one. Here, I'm just opening brackets. This times this. I open the brackets. This multiplies here. This multiplies here. And then after you cancel, then you do the mathematics. But allow me not to go deep into that. Allow me not to go deep into it. But the most important thing, what you need to know is the formula. Those who want to use the formula, that's how it comes about. People wanted to just know how it comes about. Yeah. So allow me now to say that in case you are to use that formula, in case you are to use it for your calculation, you can still use it. You can still use it. Let me, I just placed it somewhere. And then I show you how you can use it. Now, those people who want to use the formula for the first term directly, like we have said, for it, what you have to do, you'll have, this is your figure. Now, for that particular one, they gave us here, they gave you, I think it was 63. Here, they gave you 30. Here, they gave you what? 48? I think it was 48. So what you do, for you now, you just say, my volume is a third pi h. Then you say capital R, small r plus r. Sorry, r. So you'll come and let's say this is equal to a third times 22 out of 7 times, this h is the height of this first round, which is what? 63 into the big R. Here, don't forget, big R is the radius for this circle. So it will be 24. So I say 24 squared plus here, the radius is 15 plus 15 squared plus 24 times 15. So when you put in when you work out here, make sure you work out in steps. You say 22 out of 7 times 63, then work out what you have inside here. Maybe just for people who are going to use this approach, let me just put for you what you are supposed to get, such that you know what you are supposed to have inside the bracket. So here inside the bracket, you'll end up with 1161. Then you say this is a third times 22 out of 7 times 63 times 1161. So when you multiply everything, you'll come up with this is what? 63 times 22 divided by 21. Yes, you'll come up with 76626 centimeters cubed. So the same with what we had. So that is how you use it. Yes, but remember, okay, so that is how you can do it in case you have to use that approach. Yes, Daniela.
Good morning, teacher.
Morning.
I would like to ask, so this formula that you've given gives us the answer direct, so we don't have to go through the first one.
Yes, the volume. For calculating the volume, so from here you go and now calculate the volume of the bucket. The volume of the what? The number of buckets and the rest of that. The liters the bucket can carry and the rest.
Okay.
Thank you. It is but it can also but learning how to do all, it is easy. Okay, now that is the second approach. So for you, always use what you want. But here I want to repeat, it is not needed. You don't need to want to know how to derive it. But the good thing, like, I don't want you to cram. I don't want you to cram. You need to know how these things come about. Okay, now we have another one. Yes. Can I first ask everyone to first calculate for me the volume? How do you see? Everyone first try to calculate the volume for this first round before we do it together. Can that be okay? Do you get the same marks for both formulas? Yes, you get the same. Okay, let us first calculate the volume, everyone. Okay, first calculate the volume for that, for the first round, first only. Let's calculate and we see what people are getting before we do it together. Those who have just come in, don't worry, we are going to do it together, but I want people to first try out on their own to see how things are. So everyone is trying before we do it together. When you get your answer, feel free to type it in the chat. Okay, thank you, Trees. Feel free to use any formula. And now I'm going to ask people, yeah, take an example. You see there are 10 marks. Yeah. Though the marks are the same, but I would advise, my advice would be learn to derive. Learn to use the similarities. I would advise learning to use the similarities. Yeah, and that is the approach I'm going to stick on, of the similarities. Yeah, okay, people have got some answer. Martina, Andrew, Zalfa. Okay, let us go back and then try it out and see what do we get. But the most important thing is for you to know how it comes about. Okay, people have got some answer. That is good. Now we are going to do a self-check and see where are we going wrong, where. Okay, now this is our figure that we do have. Like we have said that at first, this one is always a complete figure. But later on, they go on and cut it. So now when it is like this, it is like this. So now I'm going to have my bigger cone, or what for me I call the bigger cone, which is 30 centimeters. And then I'm going to have my small cone, which is 20 centimeters, the baby one. So the baby one, I'm going to select its height be small h. Then for the bigger one, its height is going to be this 42 plus the height of the baby cone. So this is going to be 42 plus h. So using similarities, I'll have 30 out of 20 is equal to 42 plus h out of h. So I cross multiply, I'll have 30h is equal to 20 into 42 plus h. So this will give us 30h is equal to 20 times 42, that is around 840 plus 20h. So we collect like terms, we shall have 30h minus 20h is equal to 840. I'm taking this 20h this side because this side is positive. When it comes this side becomes minus. So I'll have 10h is equal to 840 divide by 10, and our h will equal to 84 centimeters. Now, after finding the height, remember I've told that, or alternatively, even people who are doing this, it is very fine, please, don't worry. Who are using this? Who are saying that this is 15 centimeters radius, and this is 10 centimeters. Then you know this is 42, and then this is h. If you are doing like this, it is very okay, don't worry. So if for you have got 15 out of 10 is equal to 42 plus h out of h, you still have the same answer. You have 15h is equal to 10 into 42 plus h. So you have 15h is equal to 420 plus 10h And then when you make this one cancel, it will be 5h is equal to 420. And when you say 420 divided by 5, you also get 84. So use any of the approaches. All the answers are the same. Now, after getting that, I'm going to come and I say now, I know this one is, my thing is 30. And my complete cone here, this is 20. And I know this is 63. And this is going to be my 84. So I say the volume. So here I say finding the volume of the big cone. Of big cone. So I'll have volume is equal to 1/3 pi r squared height. So big cone, I'll have 1/3 times 22 out of 7 times the radius. Here, the diameter is 30. So radius, we say 30 out of 2, which gives us 15. So this will be 15 squared times the height. So the height for the bigger cone, I'm going to add 63 plus 84. So you make your calculation 63 plus 84. In fact, even you can indicate that the height is going to be 63 plus 84, which according to me is 147. So I'll come here and I say this is 147. So you come, you place your calculator, and according to what I'm getting, I'll have 209,700 centimeters cubed. Then the volume for the small is also going to be 1/3 times the 22 out of 7 times its radius. Since the diameter is 10, radius will be 10 squared times the height, which is 84. And I'm ending up with 8800 centimeters cubed. Then I will say volume of the frustrum will equal to the volume of the big minus the volume of the small. So the big is going to be 29700 minus 880. And my answer, 29700 minus 8800, it is giving me 20,900 cubic centimeters. Now, what are you noticing? That this is the volume. But when you read the question, they asked you, determine the capacity of the bucket in liters. Now, the capacity in liters, then you are going to come back and say, 1 liter is equivalent to 1,000 cubic centimeters. Then you ask yourself, what about when I have 20900? What will I have? It means that I'll have 20900 divided by 1,000. And this one is going to give you 20.9 liters. So meaning that that bucket, they can carry the 20.9 liters. And in fact, you are going to find out that in many of the things in real life, that thing, like when you see 500 mils, at times it's not exact. In most cases, it might be even less than that or bigger than that. So always, it is not exact, but now this is what we have. Yes, Queen. Yes, Queen. Okay. Liz?
Good morning, teacher.
Good morning.
I'm just confused how the 63 comes about.
There?
Can you please, like the 63, how does it come about? Can you throw more light?
How does it come about? Hey, wait. Oh, it was 42. Sorry. This is 42. It was 42, sorry. This is supposed to be 42. Oh, yes. Okay, this is 42. Okay. I am going to change here. This is supposed to be, oh, this was okay. Okay. So this is 42. Thank you for the correction. Okay, let me check. 42 plus 84. This is 126. Okay, this is 126. Let me check. 15 squared times 126 times 22 divided by 21. Okay, the rest is okay. Apart from that, this is 80. Thank you for the correction. Okay. Oh. Okay. Okay. I know the answer is okay. I had calculated it. Okay. Okay, now, what if you don't use this? Now, people want to use the formula. I'll come and I say, this is 42. Make that correction. Now, you come and I say, volume is given by a third pi h into r squared plus r squared plus r. So I'll come and I say, a third times 22 out of 7 times 42 into the r, which is 15 squared, plus 10 squared, plus 15 times 10. Those who are using this. So this will be a third times 22 out of 7 times 42 times. First deal with what is inside. Eh? So you say 15 squared plus 10 squared plus 15 times 10. So here inside, I'm ending up with 475. Then after I multiply, for me, what I do, I first multiply all the things I have up. So I say 475 times 42 times 22. So I end up with 438,900 out of. Then down I have 21. So here I divide by 21. So I'll end up with 438,900 divided by 21. I'll end up with 20900 centimeters cubed. Then after getting this, you come to this step of letting. Okay, members, let me hope that is okay. Yes, yes. So I think I was comparing to the other question, but this was 42, not 63. But the answer is the same. Okay. Yes, Queen? Queen? Okay. Now that is
I
the...
wanted.
Okay.
How do you solve if the height is not given?
Oh, now when the height is not given, that is where I said that here you'll be calculating the volume scale factor. Maybe now when it comes to now volume scale factor, okay, now volume scale factor is always given by linear scale factor cubed. So here they can give, when they give you the volume of the cones, you compare the volume and then you compare the linear scale factors. Here you can compare the diameters in case they have been given or the radius when they have been given.
Thank you, sir.
That's what you compare to. Okay, then number 2, the number of buckets that must be drawn to fill the tank. Now, to get the number of buckets you need, you go back. Now, here, and please don't forget to label your work. So I'll say Roman 2, number of buckets. So number of buckets is going to equal to, now, how do you get the number of buckets? Now, you need to know, before you get the number of buckets, it means that you need to know what is the volume of the tank. That is the first thing. Because to get the number of buckets, I'll get the volume of the tank divided by the volume of the bucket. I have the volume. So what are you going to do? You're going to ask yourself, you go back and read through the question, because our question was telling us that they have given us a cylindrical tank of diameter 2 meters and height 1. Like I've told you earlier on, please make some simple sketch. So I will say tank. Now they have told you it is a cylinder. You know a cylindrical tank, and they have told you it is what? It has, they gave us what? The diameter, I think. They gave us a diameter of 2 and height 1 meter. Now, I want you to take note. This is the height, which it is 1 meter. And then the diameter is 2 meters. Now you are noticing that here we are dealing with meters. Yet initially we were dealing with centimeters. And you know very well that in 1 meter, we have about 100 centimeters. And don't cram, go back and use this. Is it King Heldy died? Many dogs cried much. That's what I remember from our primary. So now what you need, this is meter and this is centimeter. So how many? 1 meter has 100 centimeters. So in 1 meter, where you are seeing 1 meter, instead of using 1 meter, I'll use 100 centimeters. So this one is equal to 100 centimeters. Instead of 2 meters, I use 200 centimeters. Now I come, what is the volume of the tank? This one being a cylinder, we know that a cylinder is given by pi r squared what? Height. So I'll say this is 22 out of 7 times the radius. This is a circle. If it is 200 centimeters the diameter, meaning that its radius, in fact, even indicate that radius will equal to the diameter out of 2, which will give us the diameter as 200 divided by 2, which is 100. Then I'll say here my radius is 100 squared times the height. It's not 1 meter, but I'm using 100 centimeters. So I'll use 100. So then I'll come place your calc. When I place mine, 100 squared times 100 times 22 divided by 7. I'm getting this as my answer, 3142857.143. I've told you always write your answer to at least 3 decimal places if you have not reached the final answer. Now, this is the volume of the tank. Now, I'm going to ask myself, what do I have? I have already got the bucket in liters, the capacity. Can I also change this? Why did I take them in centimeters? If you had converted to meters, if you had left you had worked in meters, it means that now you need to find out the equivalence of meters and liters. Yet the one you know already, the easy one that you know that in 1 liter, you have 1,000 centimeters cubed. So now I'll come here and I say, now the volume of the tank in liters. So I'll say now it's going to be 3142857.143 divided by the 1,000. So when you calculate, this is about 3142.857143 liters. That is now my volume of the tank. Now, what am I going to do? To find the number of buckets that are going to fill the tank, I'll say to get the number of buckets, I'm going to get the volume that this tank can carry, which is 3142.857143 divided by the volume of the bucket, the liters of the bucket. Now, when you go back the liters, I think we had 20.9. So I'll say divide by 20.9. So this one is going to give us, when you do, it's going to give us about 150.376 buckets. These are the buckets that we need. Now, after, remember they have asked us how many the question wanted. The number of buckets that must be drawn to fill the tank. Now, you're going to ask yourself, can this one be realistic? So here, you are going to make an approximation. Now, use the chart to tell me, what approximation are you going to make? What approximation are you going to make? 151, that is Daniela. Another one? Now you are very good. Yes. Yes. So we shall now conclude and say that we shall need approximately 151 buckets. Reason being is that when you say 150, it means that the water you are going to be carrying is not going to be enough. So you'd rather bring another extra bucket, you pour the remaining water that you need to fill the tank, and then remain with other water in the bucket. So that's how you must conclude. Then, like even in your conclusion, you will say, I want you to use the word approximately because it's not exact. So you say that the number of buckets that must be drawn to fill the tank should be approximately 151 buckets. That's how you can conclude. Hope that one is very fine. Now, after finishing that, now for people who, let me say, who terminate their decimals here very quickly, for you, you are going to find yourself that you are going to get your answers 149 in case you approximate your decimals quickly. You'll find that your answer is less than that. Yes, I've said why 151 is that when 151 helps you to fill the tank very well, and you remain with some water, it is better you bring in excess than you bring something that is not going to be making the tank full. Yeah, 150 will not make the tank full because there are some remaining 1.376. So in order for you to fill the tank to the brim, then you need to bring some extra. Otherwise, if you don't bring something, the water will not be enough. Yes. When you refer. No, like now here it is reasoning. It's not about only rounding off. When you round off and you get 150, it means that the tank is not going to get full because there is 0.376. There is some water that is needed to make it full. So that water that is needed is that extra bucket you are going to bring, you fill it, and then you remain with the thing. So you'd rather prefer someone who brings for you the water. Yeah, even that answer. Yes, even that answer of 151.0081, approximate 152, I told you that having something in excess is better than having something that is not going to be enough. Coming an hour early to the meeting is better than coming late just by 1 minute. So I would rather prefer someone who comes 1 hour early than someone who comes 1 minute late. So having something in excess is better than having something that is less. Okay. Hope that is very fine. Now the next one. Here it is your reason. That's why I'm saying conclude in wordings. Someone should be able to read your wordings. Okay, now we go to the next one, part B. The amount of money needed to make 1 liter of the mixture. Remember, I think I showed you at the beginning. In fact, I took the pictures yesterday of this bucket. You know, this bucket here, the bucket you are seeing here, I found it somewhere. Now, when you look at this bucket, these are the buckets they're using to pack the mixtures for the colors. And when you go to buy those colors, at times we have those colors that are mixed. You learned about colors. Those colors don't just come abruptly. You have learned about colors, the red, the green, the blue, and the rest of that. In order for them to get those colors you see, or to get the white, it means that white, they mixed about 3 colors. So if for you don't want to buy that white color, that means you have to buy the red, you have to buy the green, you have to buy the blue, such that you mix for yourself. So the question here is, if someone who's buying the red one, you buy the blue one, you buy the green one, different, and you mix them yourselves, and someone who buys one that is white, that is the kind of scenario we want to bring out. So how do we come up? Now here they are telling us, okay, we go back. They are telling us that 360 liters. Now I want you to take note, 360 liters of a homogeneous paint is made by mixing. Now, I want you to take note that one topic you need to master is the topic of ratios and proportions. Ratios and proportion can appear in all the 3 elements on all the 5 elements on all the constructs. It can be there. So it can appear in each and every number. It is very possible. So you need to master that topic of ratios and proportion. It can cut across because it has a wide range of application. Now, when they talk about homogeneous in English, it means similar, of the same kind, alike. And in maybe yes, that is the meaning. Same, similar, like that. So now they're saying 360 liters of the same paint is made by mixing 3 paints, A, B, and C. The ratio by amount of paint A to paint B. Now here 2, you bring in your ratios. A to B, that is the meaning that A to B is equal to 3 to 2. Then B to C is equal to 1 to 2. Paint A costs this, paint B costs this, and paint C costs per liter. Now they're asking, if you are to mix these ones here, the 3 colors, the three paint A and B, C, if you are to mix all these ones to form one homogeneous paint, one paint, how much do you need? How much money do you need? Now, the first thing you need to first understand is that the liters you are forming are 360, and those liters must have been obtained when you mix A, B, and C. But when you look at the original ratios given, you are noticing that B for the first mixture has 2 parts. For the second mixture has 1 part. You need now to bring in the ratio. Because here now, I don't want you to hurry and just say, A has 3 parts of the 5 parts. B has 1 out of the 3 parts. No. In order for you to find out now the total ratio, it means that you need to know what happens when I mix all the 3. Now, in order for you to be able to mix out the 3, you must first ensure that the common letter in both ratios has the same number of parts. So here the common ratio is B, the common letter is B, and here the common color is B. Let me say it is blue and blue. So in order for you to solve this question to get the total parts that will mix up to the 3, it means that you must you first make it have the same parts. So here it has 2, here it has only one part. So to make it have the same, what do? You come here, you check yourself. You say here has 2, here has 1. So it is just a matter of you. You know these are ratios. It is just a matter of you. Here in case it has 2, here it has 1. Here I will multiply by 1, here I will multiply by 2. Such that the whole of this here, 3 and 2, I multiply it by 1. Here the 2, I multiply here and here, such that they have the same ratios. Members, is that fine? Let me know in the chat. Let me know in the chat whether that we are still together up to that point. No, fine, no, yeah, not yet, no, not really. Okay. Okay, I go back. Now I'm going to start. Let me start. Now, we have paint A and B that have been mixed in a ratio of 3 to 2. I have B and C that are mixed in the ratio of 1 to what? 1 to 2. Now, I'm going to do 2 things such that you can be able to understand. Because what we are looking at forming one paint. But that paint has A, has B, and has C, mixed all of them together. They have given you the cost of A. They have given you the cost of B and the cost of C. But I want you to first know that if you work out the way they are here, B, you'll find out its money will be different. Even here, you'll find that its money is different in a mixture. So in other words, let me first use the first approach. A to B means A out of B, which is the same as 3 out of 2. Hope that one is okay. Let me first use that. Allow me to first use that approach. Let me first use that approach. I'll go to the next one. So what does it mean? When you cross multiply, you'll have 2A is equal to 3B. So here it means that when I divide by 2, I divide by 2. My A is the same as 3 out of 2B. Let me call this one to be my equation 1. Then I go to the second one where I have B and C in the ratio of 1 to 2. What does it mean? It means that B out of C is the same as 1 out of 2. Hope that one is okay. When I cross multiply, I'll have B times 2 is equal to C times 1. So it means that 2B is equal to C. That is the meaning. Now, what does it mean? When I combine this equation 1 and I combine what? 2, what am I going to obtain? So when you combine, you are going to have A to B to C. What shall we have? Our A is the same as 3B out of 2. So this is the same as 3 out of 2B. 2. This one is B. It remains 2. Our C is the same as 2B. Now, when you look here in ratios, you know that B is the same, meaning that all those B's, they can be reduced. They can cancel in simple terms. So meaning that this is the same as 3 out of 2 to 1 to 2. But in ratios, we always avoid to have the fractions. So in order for me to remove this 2, it means that I can multiply 2 throughout. So in other words, I can come and I say, here, times 2, times 2, times what? Times 2. So here, this 2 and this 1 will cancel, so I remain with 3. 2 times 1 is 2, then 2 times 2 is 4. So meaning that if I'm to mix all the 3 colors, I'll have that. First, let me know whether that one is okay now. Is that one okay? Okay, yes. Okay, that one is fine. That one is fine. Okay. Now, the second approach, method 2. Now, the second method, 2, you can say that A and B is equal to 3 to 2. And B and C is equal to 1 to 2. Now, when you look at this, you are noticing that B is common, but B here has 1, here has 2. So you ask yourself, what can I do in order for me to make them the same, to have the same digits? So the simple thing to do that in order for them to have the same digits, here, you look at what you have in the second, like in the second equation. Here I have 1, I'll multiply it here. In this one, in this first one, I had it 2, I'll multiply it by 2. So meaning that the new thing is going to be A to B is 1 times 3, which is 3, 2 times 1, which is 2. Then the second one will become A, B to C, 2 times 1, it becomes 2. Then 2 times 2, it becomes 4. Now, whenever you find that they have the same, this digit that is common to both ratios has the same thing. This is 2 and this is 2. It means that if they have the same, it means you can easily combine that A to B to C can be here. A is 3, B is 2, and that one is 4. This is the second alternative that you can use. So, but always use the one you understand best. Yes, let me pick Ray and Nyans only. Unmute.
Yeah, good morning, sir.
Morning.
Excuse me, sir. At school, when we were told, we're told about the same number like this one. But in these ratios, since we have A to B and B to C, those two statements, we just added the 2 B's. In the other part, A to B, we have 3 to 2. And here we have B to C, which is 1 to 2. So I added the 2 in the other statement with this other one to get a 3 to 3 to 2. So that's
did you get 3 to 4?
No.
Now here I want you to let me use the analogy of cooking. Take an example. You have bought rice. They are telling you that this is rice. These are 3 kilograms of rice. And in 3 kilograms of rice, okay, 3 kilograms of, I'm just using an analogy. Let me say 3 kilograms of posho, you use 2 cups of water to cook. And now here they are telling you that in 1 cup, maybe you use something different. So now here, in order for you to be able to combine that, let me say this is portion. I wanted to use something more on cooking, that when you are doing in ratios, when they say that 3 cups can mix 2 of some substance, then if they say 1 cup can mix 3, it means that there is something you need to look out for if you are to mix all of them together. Here is like they're telling you that when you get paint, in paint A, you put 2 cups of maybe something. Here they are telling that 1 cup will mix only maybe 2 cups of this kind of color. Now, in order for you to get a uniform thing, it means that those 2 cups must be able to balance. Like you must balance, yes, like balancing the equation. That B is going to be able to accommodate the A and to accommodate C in a balanced ratio. So you're looking for the balance. That's why we have to first do this, that if you are to mix all the 3 colors, you must first look out for the balance. That these 2, when you put it, it will be proportional. Like when I want you to look at it very well. When you look at A to B, here, are you noticing that our A to B is the same as 3 to 2? Are you noticing? A to B. When you extract B to C, are you noticing that BC is 2 to 4? Are you noticing? When you reduce, what do you get?
You get a 1 to 2.
1 to 2. Have we changed the original equation or they have remained the same?
They have remained.
Now that should always be our task that we look out for. So for anything you got, go back and take it in that format and see whether you get the original thing.
Okay.
Yeah.
So when I'm getting the total ratio or the final ratios, so I just use this other 1 to 2. I multiply 1 to the other one and then 2 to this other.
Yeah. So now here the total ratio of the paint that comes out when you mix the 3 is going to be 3 plus 2 plus 4, which is going to be 9.
Okay.
So meaning that remember we have the 360 liters. It means that in the 360 liters, A takes on 3 parts, B takes on 2 parts, and C takes on 4. Like in case you are putting them, like, let me say in percentage, it means that in percentages, this one will take about 33.3. Then the other one is going to take on about 22.2. Then the other one will take on something like 44.4. So each of them takes on a given component, percentage in the mixture, the whole mixture.
Okay, sir.
Okay. Now, members, let us first continue. Now, the next one, they wanted us, remember we have the amount of money needed to make 1 liter of the mixture. But they gave us paint A costs this. So we are going to first find out how much are we spending on paint A? How much did we spend on paint A? How much did we spend on paint B? And how much did we spend on paint C? Because they told us that when you mix the homogeneous, when you mix A, B, and C, we get 360 liters. So how much did we get of paint A? How much did you get of paint B? How much did we get of paint C? So now I'm going to come here and I say, oh, wait. Oh, sorry. I think allow me to create more slides here. Here. Let me create more too. Yeah. So now to find out that, I'm going to come here and I say, that now for paint A, remember for paint A, it had 3 parts. So I'll say, because remember our ratio was A to B to C, which was in the ratio of 3 to 2 to 4. And our total ratio was equal to 9. So A will take 3 parts of the 9 times the 360. So we are going to find out for this homogeneous thing, how many liters of A did they use? So when you do your mathematics, 3 divided by 9 times 360, you end up with 120 liters. Then how much did we use for A? Now you find out the cost of paint A. It is going to be 120 times each liter of A, which was 18,000. So here you'll end up with 2,600,000. something like that, Ugandan shillings. This is what you end up. Then after you go to the second paint. For paint what? For paint B, how many liters, if you are to do the homogeneous, how many of liters B do you use? So I'll say 2 out of 9 times the 360 liters. So when you say 2 divided by 9 times 360, you end up with 80 liters. Then after you find what is the cost of paint B. Now you go back, you know that paint B we used 80 liters times how much is each liter of B according to, okay, I don't want, okay, you are going to find for me that I don't remember. Okay, what was it? It was, for B, it was 24,000. 24,000. So I will say this is 24,000. And then I find out how much is that. That is about 192,000. Then I go to the last one for paint C. So you find out how many liters did they use for C and what was the cost. Can everyone first find for me that one quickly? Can someone find that one part C quickly? Everyone, let's be calculating it quickly. I'm waiting for C. Find the cost. Find the cost. Okay. Find the cost. Someone who has sent this question. Number 2. Yeah, that is still ratios and proportions. Let me look through the chat and see which answer people are getting. Yes, I want to find out how much money are they spending on C. $204, that is Queen. 204, 204. Hey, how much was the thing? Let me take you back. I think it is 12750. 12750. 12750. Yes, so here I expect you to say 4 out of the 9 parts of 360. Then get the number of liters. Get the number of liters. So for B, for C, I'm saying 160 liters. And meaning now the cost is going to be 160. Oh, 160 times, I've forgotten now the amount. But that one, put the amount you are getting. I know people are saying it is 2040, 1000. Yeah, please confirm that that is what also you are getting. We shall go with what people are getting. Yeah, if that's not what you're getting, so this was 12750. Now, after finding that, you're going to ask yourself that, what is the total amount that this person spends when he uses the homogeneous? So the total cost. So the total cost is going to be the 2160 plus 1920 plus the 2040. How much is that? How much is that? Make your calculations. Baleke is saying 61, Tekno is saying 6. Okay, so here we shall have our Ugandan shilling 6 million 0. This is what? 4 zeros. Okay, good. That's what people are getting. Now, after obtaining this total cost, remember you are looking at what is the cost of 1 liter of the mixture. 1 liter, here we have calculated, this is the amount we are going to spend on the 360 liters. But what is the 1 liter? What is that 1 liter? So now I will say cost of making 1 liter. Cost of making 1 liter is going to be 6120 divided by the 360 liters. How much are we getting? What is the cost of 1 liter of mixture now? Yes, Sean Lawrence, that is good. Lillian, that is okay. Now find out how much are you getting? 170,000. Arona, I check 17,000. Fugo, 17,000. Good. So here we shall conclude and say that we shall spend each liter is 17,000. That's how you calculate it. Yes, Trisha and nobody.
Good morning.
Yes, good morning.
This thing of ratios, is it possible, like in the enable exam, can they give us a number whereby there is one ratio that's missing and you have to find that ratio, or it's a must that they have to give us when all the ratios have their specific numbers?
No, they can give you when one is missing as well. Yeah, they can. They can tell you paint B. They can tell you paint B and C. We used maybe here we use like the way you are seeing this question. They can give you for paint B when it is 8. They give you for C when it is 160. Then they ask you to find the ratio of A to B. They ask you to find the ratio of A to C. So it can be possible. So you just need to know how you can go back in the reverse. But there you use now that total that has been given to you. Okay. Yes, nobody, but it is possible. It will always depend on how someone thinks. Yeah.
So I was guiding you on how to do that the reverse way. Yes, how do we do that in the reverse way?
Oh, in the reverse way now, you make sure you use now the total. Now there they can give you the total. They can give you the total paint that was obtained, and then they give you paint B and C. Now take an example. They can give you paint B and C. They ask you, and then they give you the total liters that were got. Then they ask you to find them for paint A. So what you do, you add paint A plus paint BC, and then find out the liters that A was taking. And after finding out, so you get the total minus the total of B plus C. Then get the total of A. After getting the total of A, you can now obtain the ratio of A to B to C. Something like that. Yeah, but that one, I think we shall look out for one question where they can ask us to go back in the reverse. Then the last part to this question was the percentage profit made by selling the mixture at 2210 per liter. Now here, you need to go back and remember your business math. Like I told you in this topic, business math can be applied. So we remember, we say that percentage profit will always be given by the profit. Now out of the costs. Now here, since we are dealing in production, I expect to say cost of production. Then times 100. And how do we obtain profit? We know that profit is always obtained from the price at which you sell, what we call the selling price, minus the cost you have incurred in the production, or what we call the cost price. Now, looking at that question, we notice that they are selling it at 2210. However, their production, how much they spent on the mixture was 17,000. So meaning they made some profits. And when you subtract, I think this is 5,100, I think. Just confirm. So if this is now the profit you are making, you have to go back and say, what was the percentage profit? So percentage profit will equal to our profit, which is 5100 divided by the cost of production, which was 17,000, then times 100. So when you reduce, you'll end up with 30%. Therefore, the percentage profit would be 30%. So meaning you are making a lot of money. So now if you are into a business and you are coming up with color, instead of you selling an individual color, selling red, you sell green, you sell blue independently, yet someone wants maybe a white color. then it is very better for you. You mix them for them and then you sell them at once instead of selling the 111. That's why when you go to those shops, you may find out that the white one, the mixture for all, is cheaper than buying an individual color. So that's why at times people prefer colors that are already mixed instead of you mixing for yourself. So, and that's why I think I don't know, I don't know what happens. Plain dresses, I don't know whether it applies, but I think I need to find out whether a plain shirt or any plain cloth is cheaper than a cloth that has, let me say it, that has what? A plain one and the one which has different colors. I don't know which one is more expensive, but I think I need to make out some research. Let me say a plain, someone saying a plain. Which one is cheaper? Someone may let us know in the chat. A plain and the one which has, yes. Plixing, that one we shall work it out when we are. Colored is cheaper. Colored is cheaper. Okay. Colored is cheaper. Plain is cheaper. I think we just need to find out. So that is how we do that particular number. Okay. Now allow me now to go on to the second part. Quickly. I don't know what's the time, but at least even if we do one number, it will be okay. Now, the second part, now those are frustrums. So for frustrums, their applications, they're mainly used in that fetching of water and the rest of that. So, but this one is just an additional knowledge that you can have at the back of your mind. Yes, let me answer Trisha and Wiz.
Good morning, sir.
Good morning.
I just wanted you to repeat the other last method that we used to get the ratios, whereby it was kind of the method of elimination in simultaneous equations.
Yes, it is. In fact, it is that. That is the approach. Take an example. Trisha, don't go off. Remember, take an example. We have this, and they have given you here C to A. In case this is maybe 3 to 2, and this is maybe 4 to 5. What you do, this is A, and this is A. Are you not seeing that?
I'm seeing it.
Yeah, now you just interchange. The parts of A in the first equation are what? How many are they?
It's 3 and 5.
And 5, eh? So what you do, in the second equation, you multiply them here. The first equation, you multiply them here.
Okay.
Is that fine? Yes, so you end up with A to B is equal to, but this 5 affects the ratio. So it will be 3 times 5, which is 15 to 10.
Okay.
Then C to A will be
12
to
15.
So what is going to be our combined ratio of A to B to C?
It's 15. No, it's to 10 to 12.
To 12, yeah. In fact, now this one even can be reduced further if you want, but no, it can't, in fact. So you end at that point.
Okay.
Okay. Then the last one, Kalema or Emma, one of you.
Good morning, sir.
Good morning.
Sir, for me, my question is about these shilling signs. Like if you use UGX, can you also use the other slashing line plus the equal?
Now that slashing thing, it's not something standard, eh? It's not known anywhere. The only thing now like if you check your mobile money or you check those messages you say, you'll notice that now we are using UGX. That thing it is not there. I don't know even where we picked it from. So stick to Ugandan shillings or to shillings. But always look at the question. Eh? The question should guide you. The units they have used is what you should stick to. Eh? So here they use shillings, so stick to shillings. In case they use UGX, use UGX.
Okay.
But avoid that cat thing. I have not seen it anywhere. Yes, Emmanuel?
So also the question about number buckets, the approximation bit.
The
approximation bit. Is it something that the neighbors agree upon to mark?
That what?
It's something that the neighbors agreed upon to mark. Let's say you approximate.
Your neighbors what?
Agreed upon to mark.
Now, is it what your neighbors agreed on to mark or?
Yeah, that's what I'm asking.
Oh, now.
Because you have to calculate the amount using the number of buckets and using the approximated amount.
No, this one is like approximation is not a UNEB thing. It is mathematical. It is mathematical in nature. It's not like math is a global subject. So everywhere, even when you go elsewhere, you'll find that when it comes to one way of minimizing errors, if you want to minimize errors, always increase the number of decimal places. If you want to minimize errors, you must increase the number of decimal places. So it's not UNEB to dictate that. Yeah, it is mathematical in nature. That the more number of decimal places you have, the more you are accurate to the answer. Hope you have got that, eh?
Yes, I've got it.
So the only thing UNEB can dictate should be those last things. And that one will only come after you have done your papers. After you have done your papers, and that even after the marking process has started. So that one will come in December, around the second week of December. Okay, but let's now go to the second part. Okay, we go to the second part, but second part we shall summarize. Now, the second part is about the first one we are using shapes of a cone and a pyramid. Now, similarly, in case it is a pyramid, the same approach. Now that's why I want you to understand. If it is a pyramid, please and please, your formula doesn't work. Don't use those formulas. Like the formula for volume, it will not work for a pyramid. Hope you have got it. So in case you find that the figure is a pyramid, please don't go on and use that formula, third pi h into r squared plus r plus r. Don't use that formula. Here, go step by step. Go step by step. Yeah. And why? And now even here, let me tell you the second secret. Why I love the step-by-step approach. The step-by-step approach, when you calculate the volume of the big, you'll get a mark. When you calculate the volume of the small, you'll get the mark. When you subtract, you'll get a mark. Now, when it comes to the formula, you'll come here, you place your thing in the formula. They give you a mark. But should you make any mistake from after placing the formula, everything is going to be wrong. The only mark you'll get is the one for substitution. Yet here in step by step, you have got your marks for finding the volume of the big, you have got your marks for finding the volume of the small, and you have got some mark there. That is the disadvantage for the formula, punching it at once. That should you make any mistake at any point, everything is going to be wrong. So you may find yourself getting only 2 marks. Yet someone here, in case he passes volume of the big, he will get some marks. He passes the volume of the thing, he gets. But in case he fails the subtraction, maybe makes a mistake, then he would have gotten better marks than you who fills in the formula. So that is now the only challenge. So please, yes, so that is the only challenge with it. Now, part B. Now, Roman 2 or the second part is where they give us these questions where we need to apply the rectangles, the squares, and the formulas for those areas. This is where I want you to put more emphasis. That when they give you questions in these scenarios, please come up with a sketch. Come up with a good sketch. Now, for this particular one, they are saying that Mr. Thomas plans to build a small house next to his main house where he can always rest from in his free time. The house is to have sides in form of a cuboid. Now here, that one should give you a hint that now it is a cuboid. I'll come. That is my cuboid. It might not be so accurate, but at least, but for you, use a ruler. Now, the house is with dimensions 12 by 8 by 4. Now, when they use those dimensions, 12 by 8 by 4, that one is the standard order of length, width, and height. So it means that your length is 12 meters, your width is 8 meters, and this one is 4 meters. So always it is in that order, length, width, height. And always you must reason that length is always the longest, then followed by the width, and then lastly, we can have the height. It is like when you are building a house, that's where the reasoning comes in, that you cannot have a very tall house when it has a small base. It will fall on you. I don't know that I've seen those houses whereby the base is very small, but the height is very high. It will fall on you because it is the base that it determines. So a strong base can give a strong foundation to the height. So the height, I know it can be bigger than the length. That one is very okay. It is very okay. But the width must be bigger. Yes. But now for these questions, always know length, width, and height. Now they went on and told you that with a pyramidal roof. So here, my art may not support me well. But for you, I know you are very good at art. So that is a simple pyramid on the top of my roof. Then they went on and said that the house is to have 3 windows of dimension 0.9 by 0.6. Now, when they talk about dimensions, those are like the length, width, height, something like that. So dimension means those units, the measurements. Now you'll come to your building and then say, and now you start putting the windows. Here you must reason also. You must reason. So you say, in case I put one window this side, I put another one here. I can also put another one in front here. Okay. And then they told you, he plans, then what else? And one door. So meaning that my door is going to be here. And I don't know whether you have noticed that for many of the houses near a door, there is always a window. That's why I'm putting my window in front. And it's always rare to find windows behind the house. Yeah, the big windows, it is rare. Mainly for these small houses. So near a door, there is always a window in most cases. Yeah. For you try to check around your house. If you have a door and there's no window around, kindly let us know in the chat. Then maybe your site engineer or civil engineer, there was. But always where we have a window, at least there is a door closed to it. Now, this is my sketch. Now, where do I expect you to reason from? When you are making your sketch, I don't expect you to have all the 3 windows on one side. To have all the 3 windows, all the doors, your answers will be correct, but at least, yes. How will you know that it's a cuboid or pyramid? Like they mention it, the house is to have sides in form of a cuboid with dimension, and a pyramid is the roof. So that's why we are putting. Then after that, you'll come and you indicate, they told that the dimensions are 0.9 and 0.6 for a window. So meaning that here, you have 0.9, 0.6, 0.9, 0.6. My sketch is not so good, but I've tried. You just need to understand. But for you, you do a better one. Then they told that he plans to paint the outer walls of the house using, let me check. Which word did we use to mean those outer walls? Which word can we use? In other words, what is the question asking for us to calculate? I told it to you earlier on as we are starting the lesson. How do we call that one? Yes, Emma? Yes. Yes?
Linear surface area.
Okay, good. Linear, okay. Lateral surface area. Very good. Now that is what they're asking us to calculate. Lateral surface area. Very good. Now we continue. Now what they want us to know? The space or area of the wall to be painted. Now you need to know. Members, do we paint windows? I don't know. I want you to look at your windows and the doors. Do they have the same color with the color you have at your outside the home? I don't know. Maybe you can. No. Someone, Ricky is saying no. Someone saying no. No, they aren't the same. No. Yeah, I think even it is rare to find that your color. Yes, always you will find that the doors, the windows, at least they have a color. It might not be exactly the same, but we don't paint. Like you can't paint glass. Assuming you have used the glass, assuming you have used, we don't paint, maybe except for maybe these other ones. So here, I'm going to come and I start. Now, since this figure, allow me to label it. Let me say, I'm going to label one side to be, okay. Allow me to label this one to be A1, this side to be A2, A3, and F4, my areas. So meaning that in order for us to get, we can first find out the total area. Then after getting the total area, then we can subtract, because we are not going to paint the window, we are not going to paint the doors and the rest of that. So those ones are not going to be painted. So we can eliminate them from our answer. So hope that is okay. Hope that is okay. But can everyone first try? Find the lateral area for the entire thing. Let us first try lateral area. So we said for lateral area, we don't put the ceiling, we don't put the floor. Let everyone first calculate that at least. Let everyone first calculate. A lateral surface area, we said a lateral means sideways, sideways. Those walls at the sides that face each other. Is what we call the lateral. So, but now, then after, we shall calculate the one for the window. Yes. So in other words, I want you to calculate. So first calculate the area of the four walls. Of the four walls. Yeah. Calculate that, calculate that. Put your answer. When you get your answer, put code in the chat and we see. Queen has got 80. Okay. Queen, is that for the total area of the four walls? People are getting 80, 80. Hope we are safe. Hope we are safe. The total, Bareke is getting 160. Okay, now I'm going to start. The first side is this one. Having 12, remember you have fours. You have this one, which has 12 and 4. Plus, you have another wall, which has 8 down and 4. Plus, you have another wall, which has 12 and 4. Then you have another wall, which has 8 and 4. So members, calculate well, calculate well. 256, 160. So here I'm saying we shall have 12 times 4 plus 8 times 4 plus 12 times 4 plus 8 times 4. So calculate, calculate. What are you getting? Allow me also to get my calc. And I calculate 12 times 4. This is 48 plus 8 times 4. Okay. Queen, you only got for 2 walls. Queen, people were getting 80. You got for only 2 opposite walls. But remember, we are going to paint around the outer. We want to paint the outer walls. So here, I hope you can agree it is 160 meters squared. Members, hope you agree with that. 160. Now here, are they meters, centimeters? It is meters. Now, after getting that one, we are going to calculate the area of the windows and the floors. Can we calculate that? I don't know whether I have space. They told that each window is 0.9 by 0.6. So calculate what is the area of the 3 windows. Then after calculate what is the area of the door. And then we get that total area of the window and the door. Yes. Yes. Yes, Nolan. Let's get that. Find out. How do you get 1/6, Martina? Yes. Martina, I don't know whether you have seen my sketch here. I've drawn for you the triangles for the 4 walls. Like when you look at your house, stretch where you are placing your left hand, right hand, the wall that is in front of you and the one behind you. Those are what we call the around. So when you add 48 plus 32 plus 48 plus 32 is what we are having. So now we are calculating the area of the window and the door. 1.62, 1.52, okay? Let us confirm. Now they told us the house has 3 windows. So I will come area, or what I can say total area of the window. So we said we had our windows. They told us windows were 0.9 and 0.6. And how many were they? They were 3. You don't need to draw like me. I'm just using it for demonstration purposes for our friends. So for the 3 windows, you multiply 0.9 times 0.6 plus 0.9 times 0.6 plus 0.9 times 0.6. So according to the chart, people are getting their answers 1.62. Then after you say, what about the area covered by area of the door? So area of the door, they told us that our door was what? 2.1 by 0.8. So mean that its area will be 2.1 times 0.8, which will be 1.68. Then after you say, what is the total area of the window and the door? So total area is going to be 1.68 plus 1.62, which will give us 3.3 meters squared. Hope members, we are on the same page. I don't know that my answers are okay. Are my answers okay? Do they match yours? 3.3. Yes. Now we go. Area to be painted. Area to be painted. So area to be painted, we shall get the other total area we had, which was 160 minus the 3.3. And I'm seeing in the chat, people have 156.7 meters squared. So that is what we have. Hope that is very okay. Hope that is very okay. Hope that is very okay. That is what we get. Now, that is the area that is going to be painted. Here, do not approximate, first leave your answer there because that area can be obtained because this is the house. So for you, you'll just paint. Yeah, where we approximate is the paint. In case it is paint, we can approximate. Then I go back. Then here you can see the area to be painted is 156.7 meters squared. This was meters squared. This one, it is 5 meters squared. Then they told you that he plans was of 1 liter tin paint, a paint tin. And like his plan is to use 1 liter of paint tin. But each tin is costing 15,000. A tin can paint 5 meters squared. So part 2, they're asking, does Mr. Thomas have enough paint for the outer walls? Because for him, his plan is to use 1 tin. Now find for him or help him to know, does he have enough paint? So that question means that we need to find out the space we have. How many liters do we need? How much paint do we need? So can we go back and now we say, can we go back and now we calculate how many tins or how much paint do we need? Hope that is okay. Now I will say the number of tins required. So to get the number of tins required, remember, we shall get our area, which is 156.7, divide by the 5 meters. So you are not seeing, what do you get? 156.7 divided by 5. You end up with approximately 31.34 tins that you need. Now, can you let me know how many tins are we going to say? What will be our conclusion? People now conclude well. Yes, conclude well, and we see 32 Trevor, good. 31, 32, 32. Yes, 32, 32, good. Yes, that is a good conclusion. Now, Antonia, Vivian, that is okay. Antonia, when you say 31 tins, I think you have seen some houses whereby the painters paint, and after they leave some part when it is not painted. Do those houses look good to you? So when you say 31, it means that the paint is not going to be enough. Now, if you say 31 and you say, and if that is, those are the cases whereby you find those painters even adding or making it more dilute because you want to save. So here, the best is to say 32 tins, because even when you go to the shops, they can't sell it for you 31.34 tins. No. So here you would say, because you can't even buy a fraction, those simple fraction. So, and you don't want to buy, you don't buy halves. So you approximate say 32 tins. Yes, Nambi. Nambi.
Oh, okay. Good morning, teacher.
Morning.
So I was asking, you know how we have 31.34 tins, and then you're saying we have to, okay, round off so that, okay, the house will look nice and all that jazz. But when we come to real life, okay, not real life, but like real math, if it's less than 5, you have to round off to 0, so it stays the same. So like, won't it
Now
like
come to real life, because the reason why we are studying math is to apply it in real life. So apply now.
Okay, applying, you have to bring an extra tin so that you finish and maybe leave some. But like in a math paper, so you have to show that it's like you have to round it off to make 32 tins, even though it's not like, even though it doesn't exceed 5.
Okay, it depends on the scenario. It depends on the scenario. It depends on the scenario. And this is where now we bring in the critical thinking skills that we have been learning, the application and the rest of that. So for you, you reason. So here it is your reasoning. In fact, even here, your conclusion, you would say, because the question, does he have enough paint? Remember, he had planned for one. So you would say that the gentleman, he doesn't have, his plan is not so good because one paint can't be enough to paint the whole area of 156.7 meters square. Therefore, he will need approximately 32 tins to have his house or wall completely painted.
Yes, teacher. Thank you, teacher.
Okay, yes. So you base your reasoning in the conclusion. Yes, Antonia?
Thank you, teacher. Now, teacher, I thought that since we cannot have tins of paint when they are in points, so we just eliminate the points and stay with the 31. But then I'm confused about the 32.
Now, when you say, Antonia, when you say 31, it means that you are going to paint your house and the color will get finished and you'll have some part that is not painted.
Yes.
So you having a part that is not painted will make your car house look ugly. So you'd rather buy an extra one and you complete the painting, everything, and then you remain with some. Other than you bring something that is not enough.
Okay.
That's why we say at least buy more. Because in the shops, rarely do they sell those points in halves. Though I know in some shops, but that one now we are bringing to real life. Yes, Kalem.
Sir, for me, what I'm asking is that if you stop on 31, that 31.34, can they mark you?
Now, your conclusion matters a lot. Your conclusion matters a lot. That's why we have two of them. So for you, first write 31.34 and then approximate. Because now here they are testing for your reasoning. Remember the new curriculum, we want that critical thinking skills, that reasoning, that can he be able to reason?
Okay.
Yes, Bridget?
Teacher, good morning.
Good morning.
Sorry to take you back, like, if they had given you that A to B and B to C, and they give, like, let's say that it's 3 to 2 and 2 to 6, would you use the other method that you gave us?
If they had given you, I beg your pardon, I want to capture.
Like, if they gave you A to B and B to C, and they give you the numbers as 3 to 2 and 2 to 6, would you use the other method, or would you say that 2 plus 2 and you get that 4?
No, here you just extract, you say 3 to 2 to 6.
Okay. Thank you, sir.
The moment you find they have the same, like in other words, Bridget, when you try to go back, and you extract these ratios, A to B must give, like here, you notice it will give you 3 to 2. B to C, it will give you the original one, which is 2 to what? To 6.
Thank you, teacher.
But when you put here your 4, you would have changed the question.
Okay, sir.
Okay.
Thank you.
Okay. Chita, Jonathan? Okay. Now let us complete the question. Does then I've told you your conclusion. You say Mr. Thomas wouldn't have enough paint to paint the outer walls. But here, even I want you now, even you can be strategic enough. Yes, you must be strategic enough. Even you can put somewhere in your working that what are some of the assumptions? Because for some of these questions, they can ask you, what are some of the assumptions you have made? You can even put some assumption and say that, assuming that the walls and the windows are not painted. And that one can be your assumption, that assuming. No, it doesn't have 31 tins. For him, his plan was that he can use 1 tin, Yeah. Yes, Rain, we can make it much better now. Yeah. It doesn't have enough paint to paint the house, since painting the whole house requires 32 tins, yet he had planned for 1 tin. Yes. Thank you, Rain. That is okay now. Then the last one, even here, they can ask how many liters, they can ask how many liters of paint does he need? Now, if they ask how many liters of paint does he need, then you need to know, you'll have to know that in 1 tin, that these are the liters I have. Then part B, how much money will he spend on paint for the whole house? That one, I think everyone can calculate and put your answer in the chat, because they're saying that each tin costs 15,000. So can we calculate how much does he need to spend on the whole house? 48,000. Yes. So you'll get 48,000. Yes. That is beautiful. That is beautiful. So please check out that is your answer. And please, with such a question, you'll have got all your marks. But don't forget to sketch. Don't forget to sketch for such numbers, such that at least you are there. Yeah. For me, what I want you is that for you put everything. Let them look for what they want, such that they don't have excuse, and that you didn't have this, you missed an A+ because of this. For you put for them, such that they have no question to ask. But don't worry, we shall have a seminar, God willing, when you go back to school in September, the final one. Yes, Benjamin.
Excuse me.
Yes.
Yeah, was it necessary to put it at the roof?
For that?
Because I see, like, on the calculations, the roof. Was it necessary to put it there? Because we don't need it when you're calculating.
Yeah, we don't
because
need
actually
it.
the question was asking us, yeah. So is it fine like we draw only the whatever without putting the other row?
Okay, now putting the loop, like it shows you have understood the scenario and you have figured it out. That is it. But other questions can come because now here, take an example, they can ask you for part C. They can ask you to maybe estimate, in case he's using iron sheets, how many he will need. Something like that. They can ask you something like that. They can even ask you, at what angle should the roof be elevated? Some questions of that nature. Yes, but this was a mock paper. Like I told you earlier on, we are still in the learning process. We are still in the learning process. So the questions are not yet the best, but we are getting there. In 5 years' time, we shall be there. Yes, but now in that roofing, if you can look at the sample UNEB paper they gave you, if you have that paper, you can look at the roofing part. They can give you this house, they ask you for the paint, they can even ask you how many iron sheets will you need, what, and the rest of that. So there is a lot. Members, don't you think we have finished this one? Okay, there we have our 20. Then we have this one. Yes, we have this one, but let me look at the time. Okay, we have a few minutes to go. You first read through. Read through, because I may leave it as an exercise for us. Read through as I pick some hand here. Oh, it is down. Read through that question. Read through. Good enough, everyone has gone. Okay, read through. Yes, Nyombi Imran and Anne.
Good morning, sir.
Good morning.
My question was about the volume stuff, as in, can you use 3.1 for when you're calculating?
No, the answer is no. For pi?
No, when you're calculating for volume, instead of using 22 out of 7 and you use 3.1 for pi.
No, the answer is no. I said, now that one, 3.1 for like I've told you, whenever you terminate, you get or you diverge away from the right answer. Yeah, that is now the problem. Yes, so you'll be like opening up a space for very many errors. So you'll find that instead of getting maybe 30 as your answer, you are getting an answer below. So the lesser the number of decimal places, the far away you go from your final answer.
Okay, thank you.
So only use it when they have told you in the question that assuming that pi is this, but the moment they don't, please never approximate.
Okay.
Yeah. Members, the answer is what? 480. 480. For me, I read it as 480,000. So it is 480. The answer is okay. Then Anne?
Good morning, teacher.
Good morning.
Teacher, I'm sorry to ask on the first question that we did. Is it right, like instead of using the word homogeneous, they bring similar?
Yes, they can use. Yeah, now here, just because at times when they are setting, they want to use some vocabularies and the rest of that. But they can use similar, they can use the word comparable, equivalent, analogous, correspondent, matching, all those congruent, all those are the same words. Parallel, they have almost the same meaning.
Okay, thank you, teacher.
But always expect a simple language for easy understanding.
Okay, teacher.
Okay. So please here, people were asking, how did the people get 480? Remember, you had 32 teens. And as if the question was telling us that each teen is 15,000. So you say 32 teens times 15,000. And then you get 32 times 15. That is 480,000. Yeah. And please don't forget, some of you may end up writing 480K. Please avoid those things. Okay, now we go to this one. Yeah, this one we are going to stop at a sketch, no problem. Now, when you look at this number, you ask yourself, I've told you for these numbers, make a sketch. So let me expect now everyone to have made a sketch. Now they told that a family decides to paint the inner walls of its living room for New Year celebrations with a budget of 400. The room is 5 meters long, 4 meters wide, and 3 meters high. Now, what do I expect you? You first come up with a good sketch. Always come, you draw, you know a room. Those people who are not doing art, try to do your best. So I'll assume this is my room that I'm going to paint because I'm celebrating Easter or Christmas or anything. Now, after drawing your room, go back and read the question again. The room is 5 meters long, 4 meters wide, and 3 meters high. So now my sketch, like you must draw a talking sketch, but forgive mine, but for you drew a better one. 4 meters high and 3 meters like that. That is the first thing. Then they told you that the room has 2 painted doors, meaning that the doors are already painted, no need to repeat them, in the middle of the walls. In the middle of the walls, opposite to each other. Now come. Oh, where is my thing? Come, put your doors. Allow me to put to, I don't know. Our doors are always black, I think. Now, let me assume this is where one of my doors is, but they have told you it is opposite to each other. I have another door here. Those are the 2 doors. And they told you that the dimensions for those dots, they gave them to us. Then you go back. The doors are 2 meters high and 0.7 meters wide. So you go back and put that the height here is 2 meters and here 0.75. Here the height is 2 meters and here 0.75. Then they told you that you have interpreted up this point. Then you said the room has one painted window in one of the side walls, which is 1 meter square. 1 meter square. Then you come. This room has a window. So for you, this one, you put it anywhere you want. You don't need to anywhere. So let me put it here. And they have told us it's the square of 1 meter, meaning here you have 1 meter, here you have 1 meter. That is now we are doing our sketch. Then after you say, a painter charges 800 per square meter painted. And for every 10 meter square wall painted fully, consumes 4 liter tin paint, which is sells at this. Now, the first thing you're going to find out is that establish computations, find out if the budgeted money could be enough for this work. Now, what do you need to know? I'm going to come here and I ask myself, if they are painting, let me look at your reasoning. In the chat, you can tell us, when you are painting at home, do you count the ceiling to be, part of the things? Do the ceilings always have the same color with your walls or they differ? I don't know. No. 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 They differ, yes. No, they are different, yeah. Okay, yeah, because where I am, I'm looking at my ceiling. The ceiling has white, the walls have another color. Yes, so they differ. They differ, good. So meaning that for this particular case, those are some of the assumptions I'm telling you, because I want you for you always to reason mathematically. And you say that some of the assumptions I'm going to take, that the ceiling is not going to be painted under and the downer floor, because you may have tiles at home. We don't paint the tiles. So you say the ceiling, or even you can assume that the house has no ceiling. That one is also very fine. So in case they ask, what are some of the assumptions you have made? The house has no ceiling. The floor is not painted because I am using tiles. Even other colors, because I have not seen them painting that. I have even something, maybe I have a carpet. So what does it mean? We are going to calculate the lateral surface area of the inside walls, the walls inside. So meaning, can everyone first find out the total lateral area for that figure? Yes. Can we find it out? Yes. Let's calculate. Calculate. Yes. Yes, very good, Trisha Conqueror. Yeah. Let's now calculate 54. Yeah. Yeah, some people don't have a ceiling, which is very fine. Yeah. So, 54. Everyone is getting 54. Very good. So I'm going to say the total area. In case you are not getting that one, please you check out. So the total area, it's going to be the 4 walls, whereby now those who are not yet there, this is 5 meters and 3 meters. Plus, you have another wall that is this side. You have this side, which is 4 by 3. You have another one, another wall this side, which is 5 and 3. Then you have another one, which is 4 and 3. So when you multiply, you say 3 times 5 plus 4 times 3 plus 5 times 3 plus 4 times 3. So this will give you 15 plus 12 plus 15 plus 12. According to the chart paper saying the answer is 53. 54, 54, 54. Good. So the answer here is 54 meters squared. Do not forget. Do not forget. Now, can we find out the area covered by the windows? Area covered by windows. By the window. And also the area covered by the door. Yes. Now, why do I always love this method of calculating step by step. That in case you fail one part, at least you can get a mark in other parts. But when you try to punch your things in one and you fail, you may fail everything. But Martina, can you raise up your hand and we talk? Martina, unmute. Okay. Yes.
Yes, teacher.
Yes. Where?
No, I was saying that getting the lateral surface area. I don't understood, but now I've understood.
You have understood now, eh?
Yeah, the demonstration.
The demonstration. Okay. So area covered by the window. Remember, we have just our 1 car window, which is 1 meter, 1 meter. So its area is going to be 1 times 1, which is 1 meter squared. Yeah. Now, yes. So please make sure you do it in step by step. The marks, at least you know that. Instead of you doing, hope you know there. You know there is that approach whereby you can punch it at once. That one is also okay for quick ones. But you make one mistake, everything. So when you look at our doors, we have also 2 doors. You have this door here, which is 2 meters and 0.75, plus the second door, which is 0.75 and 2 meters. So you find its area. So you say 0.75 times 2 plus 0.75 times 2. So I don't know what people are getting, but let me also multiply quickly here. So I'm getting 1.5 plus 1.5, and that one is 3 meters squared. Yes. People are getting 2.8. How? Okay, 3. Good. People getting 3. Now we are going to go. Total area to be excluded. Total area to be excluded will be the window and the door. So we shall say 1 plus 3, which will give us 4 meters squared. Then now we shall say area to be painted. Area to be painted. So the area to be painted is going to be the 54 minus the area of the window and the door. And we shall get 50 meters squared as our area to be painted. Very good. And you know, there's nothing that you can feel happy when you get an exact answer. That is one thing that can make you happy. Should you get points, you start even worrying, have I made a mistake? Yes, but 50 is very okay. Good. Now, we are going back. Now, after making that, like I've told you, now you can even make some assumptions, because now always you need to be a good mathematics, even a scientist, even in science, always we make assumptions that assume this and this, assume this and this. Yes, such that you know what you. So here we have said our assumption. The room has no what? Has no ceiling, or the upper part is not what? Is not painted. Or you can say the ceiling, the floor is not painted. Yeah. Yeah, such that someone marking you has to know that those are your assumptions you took. You're a scientist. Yeah. Otherwise, Wilson Benjamin. Alinda.
Yes, teacher. Like, what I'm saying is
what?
it fine if,
yes?
Is it fine if I draw the net of the figure? Because I see some of the, when you look at the small figure that you've made, the one of 5 by 3. So most of the figures have the same dimensions. So is it fine if I draw the net and then I just combine them at one?
It is very fine. It is very fine. But do not forget to do it very quickly such that time. You don't waste a lot of time. Yes. Yes, Trevor. Yes.
I was saying that I'm going to make that closing prayer. I booked it.
Okay. Okay. Help 2024. Okay. Help. Okay. Last Noelina.
Good morning.
Good morning.
Having a question about the door. Like these doors. I'm confused about that part because there are 2 doors in front and behind. But then how are you going to exclude them from the total surface area?
Remember, when you are calculating, in your calculation, the total area. Now, we're in a first unmute. When you are calculating, you remember this was the wall where your door is. So this wall was 5, 3. So its total is 15, meaning that here you calculated when everything was there. But since you have a door, you must cut it out.
Yes.
So when you cut out the door, since this area you had included it, that's why we shall remove it now. You will say now 15 minus the door, which was 2.0.75.
Yes. That's what I get. So what are the digits? 15 minus?
15 minus 2 times 0.75, which is 13.5.
Yes, teacher.
So it is okay. So this side you have 13.5, even the other side 13.5.
Okay. So I've got it now. Thank
you. Alinda? Okay, I failed to get Alinda. Alinda wanted more clarification on lateral. Like we have said, that lateral means sideways. Like when you sit in your room. Yes, Alinda? Alinda?
Teacher, morning.
Morning.
I'm requesting for more clarification on lateral area because it still confuses me with this thing of the total surface area as well.
Okay, now total surface area. Total surface area, Linda, you first keep on. Total surface area means everything added, everything you have on that figure, add it. When it comes to lateral means add only like the opposite side, sides that are sideways, minus the top and the above, minus the floor and the ceiling. Lateral is that figure that remains after you have removed the ceiling and you have removed the floor. Those walls that are opposite to each other are the ones. You call the lateral.
Okay,
Have you
teacher.
got not yet?
I've got it. Thank you.
Okay. Okay. Now let us first continue small. We are continuing with that thing. Establish the complete fund if the budget money could be enough for this work. Now we have got the area to be shaded. Now we are going to the second one. Remember, we have to look for an excellence mark in whatever way possible. That's why I'm telling you, put the assumption such that when someone is denying you that excellent, he says, ah, this student has done something exceptional. He needs it. Then now we are going to go to the next one. Now the next one that we are going to find out amount required for the paint. How much they are saying that a painter charges per square meter. Now we are going to go and find that amount for the paint. Amount needed by the painter. Needed by the painter. By the painter. So this amount, remember, he's charging 800 per square meter, and we have 50 square meters. So I'll say 50 times 800. And this will be what? Shillings. How much is it? 50 times 80. That is what? 40,000? That is the amount the painter is going to take. Not so? Yes, 40,000. Very good. Now we go back. We go back to now. We are still on the question. Now, after that, they're telling us that, and for every 10 meter square wall painted fully, consumes a 4-liter tin paint. That statement is very important. That for, now you go back, we go back quickly, and we ask ourselves, the paint required to fully paint the house, paint required to fully paint the house, the inside walls, the house. So how much space do we have? They're saying that for every, So let me see whether people can quickly do that. 20 liters. Okay, someone has got 20 liters. 20 liters, 20 liters. In paint, you require to fully paint. Fabian is saying 20 liters, which is very good. Which is very good. Okay, you first give me. How many tins do we need? Paint required to fully paint the house. So you're going to find out, are we getting 5 tins, members? 25 tins, 5 tins, which is yes. So I know people are doing like this. 50 out of 10. So this one is going to give us 5 what? 5 tins. But since we want the liters, what are we going to do? We are going to say liters required. Liters required, because they are required is going to be the 5 tins times the 4. I don't know that people are saying that, which will give us the 20 liters people are getting. We can go back. They're telling us that for 10 meter square wall painted fully consumes 4-liter tin paint. So the number of tins we want, we shall say the 50 divided by the 10. So mean that you require 5 tins, but each tin has 4 liters. That is the meaning that for each tin of paint has 4 liters. So here I will say 50 out of 10, which will give us the 5 tins. But how many liters do we have? We have 20 liters. Hope that is very fine. Okay, now after that, we are going to go on. 5 tins, very good. So we shall require 5 tins. That is very, very okay. Now, we are going to go on and find out how much money did he spend on the paint? That is now. Now I will say amount required. Okay, let me first find what is the amount per liter of a tin. Here now we are going to say, because they are telling you that each tin is what? Each tin is 70,000. I don't know whether that is okay. We go back. They told that each tin he sells at 70,000. Now you ask yourself that how much is a liter? Because you have got 20 liters you are going to use. So how much is a liter? Are we still on the same track? Yes. Now we are going to find out how much is the liter. I want to put in the chat how much is going to be a liter now. Fabian has got 175. Zulu, check 175, 175. Very good. We are there. So I'm going to come here and I say amount per liter is going to be our 70,000 divided by the 4. And this will give us shillings 17500. That means that each liter of the tin is 175. Now we are going to say amount required to buy the paint. Required to buy the paint. So to get that amount, I'll come and I say my 1 liter is 1750 times the 20 liters we need. So this will give us multiply, and we see. I saw that answer, I think, somewhere. 17500 times 20. I'm getting 350,000 members. 350,000 shillings. Are we getting the same? So meaning that your 20 liters, you'll buy 300. And I want to let you know, I heard paint is very expensive. Hey, paint is very expensive. It's not something very, very cheap. It is not very cheap as you may think. So now after that, we are going to go back and ask ourselves, what is the total expense? How much is this person going to spend just on painting? So the total expenses, we shall have the amount for the paint, add on the amount the gentleman will charge for his labor. So here it will give us 390,000. So that is the amount needed. I don't know whether we are still on the same page. 390K, very good. Oh, Vivian, which place? Vivian, let me know which place, if you can have your hand raised. Wiz, you can unmute as I get Vivian. Vivian?
Teacher, the price for amount per liter of a tin.
Oh, now they told us, okay, let me take you back here. Vivian, they told us that a 4-liter tin, 4-liter tin is at 70,000. Meaning that in one tin, it has 4 liters. Are we together on that?
Yes.
Now you ask yourself, how much is a liter? How much do you think a liter can go for if you are to buy it? So you divide by 4.
Is
that fine?
Yes.
Yeah, so that's how. Yes, so that is how you get it. Now we continue. Now here they ask you, establish the computation to find if the budgeted money could be enough for this worker. Can someone raise up the hand and give us a good conclusion? One person. Who is going to give us the conclusion? Okay, Fugo is here. Yes, Fugo.
My conclusion is his money will be enough since his total expenses only cost 390,000, leaving a balance of 10,000.
Very good. That is Fugo. Thank you, Fugo. That is correct. Yes. So that's how you have to conclude. And we say that in your conclusion, put even the figures. Since the expenses are smaller than the budget by 10,000, the money will be enough to complete the painting. Then you see how you fail to get the excellent marks. So hope you have seen. Even you look at the flow of the work. I've tried to make the work flow. Also make your work flow in a good way. Then we go to the last part. If a painter offers a discount of 10%, a discount is a reduction. Whenever you give people, when someone gives you a lot of work, at times you feel sorry. This person has given me a lot of work. Let me reduce for the person. And 5% on every liter of paint. How much money shall the family save? Imagine. So you go back, and you say now, part B. And don't forget to label, say discount on labor. So discount on labor will be 10 out of 100 times 40,000. Now that means that how much is the person removing? The person is saying, instead of giving me 40,000, I have reduced for you, give me 36,000. That is the labor. Now, since we have already, now we go back to paint. We go back to paint. Discount on the paint. The paint they have removed for us 5%. So you say 5 out of 100 times 350,000. So how much are we saving? It's going to be shillings. Place your calc quickly. 5 out of 100 times 350,000. So you'll notice that you are saving 17,500 because they ask you how much money did the family save. So you say amount saved by the family. Amount saved is going to be, you add your 70 plus the 4,000, and this will give you shillings. Add quickly. I don't know what you are getting for 4,000. I'm getting 21,500. Hope we have the same. That's how you calculate. Very good. Very good. Very good, Jane. I'm saying people have the answer. Yeah. Yes. Okay. Okay. Yeah, I'm seeing the correct answers coming in the chat. Now, when you do like that, yes, then here you can say in your conclusion, the family would save 21,500 shillings when they are offered a discount. Then that is the best answer. Now, why don't you allow me to give you some assignment to try out? Take a screenshot of that number. Okay. I know people have taken. People have taken. Yes. Yes, Ricky, as you ask. Ricky, I want to give you another number. Ricky, ask. Okay. I am giving you more numbers. Now that number we have done, it was the number in this mock paper. That's why where I picked it. I think I will send you this paper. It was Chindamitiana Diocese. Yes, that's where that number was. And yes, then I want you to, we are going to try out this one. I think we may not have a lot of time. Today we have over pushed. Don't know. So you take a screenshot of this number. Oh, wait. But I'm going to send a paper. But I know some of you may not be on the WhatsApp group. That is the number. Now, still even this one, now this one is for fixing tiles in the room. Okay. Maybe people have finished. Even you are going to try out this one. We have done a number of this nature. And you cannot see they used WB and they used BR. Yeah. Okay. Maybe people have finished. I want to give another one. Still, this is the same topic. The same topic. So here it's just a matter of you now looking at the figure and then you try to interpret. Yeah. There is another one here. Yes. Now here they have given you a net and they want you to draw the sketch. So even here, now here, these are similarities. So you need to remember those things of area scale factor, volume scale factor. Yes. So those are some of the numbers. Yeah. Okay. Yeah, I'm going to send. I'm going to send. I was just taking in case some people are not on WhatsApp. then I send you the thing. So that is, those are the few numbers that, now I don't know. Okay, now allow me to stop sharing. In case you have any question.